Welcome students. In today's class we will start off with inverse Laplace transforms. Now foremost we would like to know what exactly is inverse Laplace transform. Now for this we would have to first understand the definition of Laplace transforms, and then from then on we would be able to obtain the definition for inverse Laplace transform. So having said that, let me start off. Now imagine we are given this. So given a function f of t, whenever I say f of t, this is a function in time domain, and you are expected to obtain the Laplace transform of f of t, then that would be defined as integral 0 to infinity e raised to the power of negative s times t f of t times dt. So this is the definition we have seen, and it has a representation as f of capital F of s. Now if I want to obtain the Laplace transform of this, in fact the inverse Laplace transform of this is actually L of f of t. It can be written like this. Okay, so you have this connectivity. Now if I were to use this is called as inverse Laplace operator, right? So let me mention this: inverse Laplace transformation operator. So that is exactly what it is called. Remember that, inverse Laplace transformation operator. Now if we are going to be operating the left side and the right side by L inverse, then if I were to take this as 1, I can rewrite 1 to be as L inverse of Laplace transform of f of t is equal to L inverse of f of s. Now in this case L inverse and L, they get neutralized, giving me f of t, and this is going to be L inverse of capital F of s. So in other words, if you want to get the function back, all you need to do is operate with L inverse on f of s. We know that f of s is the Laplace transform for the function, right, from the definition. So this is what we would be doing for this course. So if you are given, or in other words, if you are asked to find f of t, we would have to use the inverse Laplace transformation operator onto f of s and then extract f of t. Now before we could start off with inverse Laplace transforms, we would have to refresh ourselves with some Laplace transforms. So that is exactly what I would be doing. Now imagine you are given Laplace transform, or you are asked to find Laplace transform of 1. So what would that be equal to? So that's going to be equal to 1 over s. Now simultaneously, if someone were to ask you, this is going to be inverse Laplace transforms. If someone were to ask you, what is the inverse Laplace transform of 1 over s? So what would your answer be? Just go to the Laplace transform. All that you're doing is, as I mentioned to you, you're operating on the left side and on the right side by L inverse. So what happens? On the left side you are all that you got is 1, but on the right side you got L inverse of 1 over s. That is exactly what they want. In other words, you can also visualize this like this: you are actually moving L to the other end. When you do that, L would become L inverse, and what is left is 1. So that is the solution for this question. Okay, moving on, let us consider the Laplace transform of t. What is that? That's nothing but 1 over s squared. Now suppose someone were to ask you, come on, give me the Laplace inverse of 1 over s squared. So what's your answer should be? It should be t. Now moving on, if someone, let us consider Laplace transform of t raised to the power of n. What is this? This is nothing but n factorial divided by s raised to the power of n positive 1. Now imagine if someone were to ask you what is the Laplace inverse of 1 over, say, let me just rephrase it, say 1 over s to the power of 3. Someone wants to know this. So how are you going to handle this? Now what you have to do to handle this, you will have to come back to this formula. Now when would you get s raised to the power of 3 over here when n is equal to 2? So just substitute n is equal to 2. You can just state it here. For n is equal to 2, the above formula can be rewritten as Laplace transform of t raised to the power of 2 is equal to 2 factorial divided by s raised to the power of 2 positive 1. Now what is this 2 positive 1? This is 2 factorial is 2, so this is going to be s raised to the power of 3. On the left you got Laplace transform of t squared. Now they want Laplace inverse of 1 over s cubed. So as I mentioned to you, I am operating on both sides by L inverse. So this is going to be L inverse of L of t squared, and this is going to be L inverse of 2 over s cubed. I don't want this 2. So in this is actually a constant, right? 2 is a constant, so I can bring this down. Now over here L inverse and L would leave me with t squared. Since this 2 has to be got rid of, I'm pushing the 2 down, so I would get t squared over 2, and on the right hand side is going to be L inverse of 1 over s cubed. So this is my solution. So that is exactly what you have to write. So this is equal to t squared over 2. Of course, I can simply write the final solution there, but that would not serve the purpose. The exact purpose is to explain to you how I'm getting that. So let's move on to the next question. Now with this we can extend the result. Now, what if someone were to ask you what is the Laplace inverse of 1 over s raised to the power of n positive 1? If a thing like this were to occur, what would you write? So this can be rewritten as, now just go back here and watch the result. I can very well correlate. When I have n is equal to 2, I get t squared, and then this is actually 2 positive 1. So that means the value of n is 2 here, and the same 2 occurs here with the factorial. Of course we have simplified this. So this outcome can simply be written as t raised to the power of n divided by, now in this case I've got a 2 here, but this 2 is actually 2 factorial. Now why did I place this 2? Because I know that 2 factorial is actually equal to 2. So that's the reason I simplified and placed the result. But in this case they are asking us for a generalized term called n. So this should be n factorial. Now sometimes it is necessary that you remember the results, because for being efficient and also for bringing the time down, so such results are critical. So having obtained this, let us go on a step further. So I would like to introduce to you another question. Say suppose someone were to ask you what is the Laplace inverse of 1 over s negative a. Okay, this is a valid question. How would you handle this? Now to handle this question, we would have to study the Laplace inverse of e raised to the power of at. Now we know this is nothing but 1 over s negative a. Now since I have told you, if there is a question where we are expected to find the Laplace inverse, it would be actually the left side and the right side would be operated upon by the inverse Laplace transformation operator, L inverse. So have that in mind. So when I use L inverse on both sides, I get here e raised to the power of at. On this side it's going to be L inverse of 1 over s negative a. So this is exactly what we have got. Now this is what they are asking. So all that we need to do is just substitute e raised to the power of at. So that is the solution for this question. Now going further, what if they ask you what is the Laplace inverse of 1 over s squared positive a squared. There is a question like this. So for that, let me just use this part. Okay, so L inverse of, now we know that L inverse of sine AT is equal to a over s squared positive a squared. Now just make an observation. They are asking us to find 1 over s squared positive a squared. So I can rewrite this by L inverse. In fact, using L inverse, when we use L inverse on left side and right side, this is going to be my sine AT, right? Because this L and L inverse will get neutralized. But on the right hand side, I would have a L inverse of a over s squared positive a squared, right? But I don't need this a. So what should I do? I need to push this a down. When I do that, this would actually be sine AT over a is equal to L inverse of 1 over s squared positive a squared. Now this is a very important result. So whenever you get this, you might be asked to find what is L inverse of 1 over s squared positive 16. Questions like this. You might be asked to find what is L inverse of 1 over s squared positive 36. You might be asked to find what is L inverse of 1 over s squared positive 121. In each of these cases, try to write the question as 1 over s squared positive 4 squared. This is going to be L inverse of 1 over s squared positive 6 squared. This is going to be L inverse of 1 over s squared positive 11 squared. So once you do that, the solution is straightforward. So clearly in this case, L inverse of 1 over s squared positive a squared is sine AT by a. So this is going to be sine AT over a. And this is going to be sine 40 over 4. This is sine 60 over 6. And this is sine 11t over 11. So straightforward. Okay, so let's do this question. They're asking us to find the Laplace inverse of, say, s over s squared positive a squared. So how would we do this? Now we can actually correlate this with the Laplace transform of cos AT. Now Laplace transform of cos AT, what is that? Cos AT is nothing but s divided by s squared positive a squared. Now taking Laplace inverse on both sides, this is going to be Laplace inverse of Laplace of cos AT, okay, is equal to Laplace inverse of s over s squared positive a squared, and this is going to be cos AT is equal to Laplace inverse of s over s squared positive a squared. So this is going to be cos AT. But they are not going to be asking us straightforward in this fashion. Say, give us the Laplace inverse of s over s squared positive a squared. They would ask us questions like this. What is the Laplace inverse of s over s squared positive 16? So what you have to do, you will have to rewrite this as L inverse of s over s squared positive 4 squared, and then we know that in place of a I got a 4, so this is going to be cos 4t. Okay students, we're given a question to find the Laplace inverse of 1 over s squared negative 1. Now we know what is Laplace inverse of 1 over s squared positive 1. But how are we going to obtain the result for Laplace inverse of 1 over s squared negative 1? So for that, we would have to use the Laplace transform of Shin AT. A over s squared negative a squared. So this is the formula. Now if a is equal to 1, then I can rewrite this as Laplace transform of Shin t is equal to 1 over s squared negative 1 squared. 1 squared is going to be 1. Now, using the Laplace inverse transformation operator, this can be rewritten as shin t is equal to L inverse of 1 over s squared negative 1. So from this time forth, I will be using curl parenthesis instead of flower parenthesis. So this is going to be L inverse of, in fact, this is the question given. So the solution for this is going to be shin. Now, what if they have given us, say, something like this, say Laplace inverse of, say, 1, probably 1 over s squared negative 25. How would we handle this? Now, let us go back to the Laplace transform of shin at. So this is nothing but a over s squared negative a squared. Now, what is Laplace transform of shin 5t? Now, this is nothing but 5 over s squared negative 5 squared. Now, if I were to apply the inverse Laplace transformation operator on both sides, this would give me shin 5t is equal to Laplace inverse of 5 over s squared negative 5 squared. But I don't need to have a 5. In fact, the question wants us to have a 1 as in this case. In the numerator has got 1. So I need to push this. So this is going to be Laplace inverse of 1 over s squared negative 25. And on the left side is going to be shin 5t divided by 5. So this is going to be my solution. So I need to write the same thing. So Laplace inverse of 1 over s squared negative 25 is going to be hyperbolic shin 5t divided by 5. So that is the solution for this question. Okay, now having obtained this, let us move on to the next question. Suppose they are asking us to find the Laplace inverse of, say, s over s squared negative 25. So what would the Laplace transform be in this case? Now, to solve this question, let me just draw your attention to the Laplace transform of cos at. The Laplace transform of cos at is nothing but s over s squared negative a squared. So the Laplace transform of cos 5t is going to be s over s squared negative 5 squared, which is s over s squared negative 25. So the Laplace inverse they want. So this would mean the Laplace inverse of s over s squared negative 25 will be equal to cos 5t. So that would be the solution, cos 5t. So we got a list of questions. We got 5 of them. Can you try these questions out? Maybe you can pause the video for a minute and get the solutions done. Okay, I hope you all got the solution, students. So the first one is, we are expected to find the Laplace inverse of 1 over s squared negative 36. So I would like to write that as L inverse of 1 over s squared negative 6 squared. This is very similar to the question that we just did, and so I can rewrite this as hyperbolic sine or shin 60 divided by 6. You can either write it like this, or you can write it as 1 over 6 times shin 60. So that's the solution for this question. So this is s squared negative 16, so I can directly write this as 1 over 4 times shin 40. So that will be the solution for this one. And this is s over s squared positive 16. So this is my s. So this is very much similar to the cos function which we have studied. So I can rewrite this using the Laplace transform of cos, and that would give me as cos 16 is actually 4 squared, so that's going to be cos 4t. And this is hyperbolic cosh, I know that, so I can rewrite this as cosh. And one more thing, this is not 25, this is 5, so let me show that to you. So this is L inverse of S over, I'm going to write this as S squared negative root of 5 squared. So that would mean this is going to be cosh root of 5t. That's because of the value given, 5. And this is, as usual, our cos function. This is S over S squared positive 25. So this is going to give me cos 5t. So I have completed the solution for all the questions. So we will move on to the next problem solving session. Students, we have a set of questions. You can pause the video and try these questions. Okay, so let us start off with question number 1. So we got to find L inverse of 1 over S raised to the power of 3. Now we know that L inverse of 1 over S raised to the power of n positive 1 is equal to t raised to the power of n divided by n factorial. We know this. Now you can either use this formula. I can give you another deduction. Say L inverse of 1 over S raised to the power of n is equal to t raised to the power of n negative 1 divided by n negative 1 factorial. So you can either use this formula or this formula. So in this case, I'm going to show you by using both these formulas. Now you can try yourself which one you want. Now first I would be using this one. So L inverse of 1 over S raised to the power of 3, I would like to write it as 2 positive 1. So in this case my value of n is 2. So using this formula, this is going to be t raised to the power of 2 divided by 2 factorial, which is t squared over 2. So this is the solution. Now using the second formula, using this one, I don't have to write it as 1 S raised to the power of 2 positive 1. I need to just retain the given form 1 over S raised to the power of 3, and then what I need to do is I need to just deduce 1 from 3. So that's going to be 2. Again deduce the element 1 from 3, that's going to be 2 factorial. 2 factorial is going to be 2. Now you can repeat this process. In fact, if someone were to give you a question, say find the Laplace transform of 1 over S raised to the power of say 19, all you need to do is come over here, place t, deduce 1 from 19, that's going to give you 18, and divide by that 18 factorial, and that will be the solution for this question. So imagine someone were to ask you find the Laplace transform of 1 over S raised to the power of 121. All you need to do is take t, deduce 1, that's going to be 120, and divide by 120 factorial. So that will be the case. If you don't want to use this, then you can try this. In this case you need to split it and write this as 1 over S raised to the power of 120 positive 1, where the value of n is 120. So that's going to be t power n, that's 120, divided by n factorial, that's going to be 120 factorial. So whichever is your liking, you can go with that. Find the Laplace inverse of 1 over SO over 3 over 2, and Laplace inverse of 1 over S raised to the power of 5 over 2, and Laplace inverse of 1 over S raised to the power of 7 over 3. Now all these three quantities have got a fractional component, so that would mean we will have to adopt a different formula altogether. Now in the previous question, if we were to be given Laplace inverse of say 1 over S raised to the power of n, then we have two formulae. I will be using this formula, which is t raised to the power of n negative 1 divided by n negative 1 factorial. And I also gave you another one, which is L inverse of 1 over s raised to the power of n positive 1. Then this is going to be t raised to the power of n divided by n factorial. Okay, so you have the choice to use whichever you want, but I would be using this one for this particular question. Now, in this case, the n that we are talking here takes the value from 0, 1, 2, etc. It doesn't take a fractional component here or a fractional value here. Now, what happens when n is a fraction? If n is a fraction, then Laplace inverse of 1 over s raised to the power of n has a different formula, which is t raised to the power of n negative 1 divided by gamma of n. So this is the formula we will be using. Now this is called as gamma function, right? And for this course, all that you need to know is gamma of 1 over 2 is root of pi. And I will show you how to evaluate, say, if you are being given, say, gamma of 3 over 2. All you need to do is start off by subtracting 1 from 3 over 2. So that would give you 1 over 2. The moment you reach 1 over 2, place gamma of 1 over 2 with that. So that would mean this is going to be 1 over 2 times root of pi, since gamma of 1 over 2 is root pi. So this is the value. Now suppose you encounter gamma of 5 over 2. You start off by subtracting 1. That's going to be 3 over 2. Again you subtract 1 from this. That's going to be 1 over 2. The minute you see 1 over 2, place a gamma of 1 over 2. So this can be rewritten as 3 divided by 4 times root pi. So that's all you need to know for this particular course. That's the minimum requirement. So having understood this, let us go and find what is Laplace inverse of 1 over s raised to the power 3 over 2. So this is going to be t raised to the power of 3 over 2 negative 1 divided by gamma of 3 over 2. Now 3 over 2 negative 1, that's going to give me, let me show that, 3 over 2 minus 1. I take the LCM as 2, is going to be 3 negative 2, which is 1 over 2. So this is t raised to the power of 1 over 2. And as I mentioned to you, we start off by subtracting 1 from here. So that would give me 1 over 2. The minute you see 1 over 2, place gamma of 1 over 2. So this is going to be t raised to the power of 1 over 2 divided by, I got a 1 over 2, I can flip it. So it goes to the numerator. And gamma of 1 over 2 is going to be root of pi. So I can rewrite this as 2 times root of t divided by root of pi, and I can also rewrite this as 2 times, probably I'll write it here, 2 times square root of t over pi. So that's the solution for this question. So probably I can move on to the next question. So I've got this question, Laplace inverse of 1 over s raised to the power of 7, let me do this, 5 over 2. Okay, so this is going to be t raised to the power of 5 over 2 minus 1 divided by gamma of 5 over 2. This is going to be, you subtract 1, so that's going to be t raised to the power of 3 over 2 divided by, you start off by subtracting 1 from this. So 5 over 2, you subtract 1, you get 3 over 2. So just place that, that's going to be 3 over 2. Again you subtract 1 from this, that will land you up at 1 over 2. When you receive 1 over 2, just place gamma of 1 over 2. So this is nothing but t raised to the power of 3 over 2 divided by, you have 3 over 2 times 2 is 4 times gamma of 1 over 2 is root of pi. So you flip this, this is going to give you 4 times t raised to the power of 3 over 2 divided by 3 times root pi. And that's a good place to stop with regard to the solution is concerned. Probably you can do some simplification with regard to representing t, but that's up to you. Now the next question, Laplace inverse of 1 over s raised to the power of 7 over 3. This is a critical question. You need to pay focus attention to this. Now this can be rewritten as t raised to the power of 7 over 3 negative 1 divided by gamma of 7 over 3. Now this can be rewritten as t raised to the power of, I subtract 1, this is going to give me 4 over 3 divided by, I start subtracting 1, so 7 over 3, I subtract 1, I would be getting 4 over 3, so place that 4 over 3. Again you subtract 1 from this, so subtract 1 from this, so that's going to be 1 over 3, place 1 over 3, again you subtract 1 from this. The moment you do that, you get negative 2 over 3, so we can't place negative 2 over 3 there. So all you need to do is just place this value, gamma of 1 over 3. Okay, substitute, just place gamma of 1 over 3. Now how to calculate gamma of quantities like this? We will have to wait for the other course, because given the expectation for this course, I feel that we shouldn't be complicating issues with quantities such as this, which is not really required for this course. So if I were to simplify this, this is going to be t raised to the power of 4 over 3 divided by, this is going to give me 4 over 3 times 3 is 9 times gamma of 1 over 3. So if I were to flip this, I would get 9 times t raised to the power of 4 over 3 divided by 4 times gamma of 1 over 3. So this is a good place to stop. So that is the solution, students, for this question. Now we have been given this question. We are expected to prove that Laplace inverse of 1 is equal to 0. This is a very important result. Now to prove this result, what I would do is I would start off by using the result that Laplace inverse of 1 over s raised to the power of n is equal to t raised to the power of n negative 1 divided by gamma of n. Okay, so having mentioned this, let me just take n is equal to 0 here. So that would mean this entire thing is going to be Laplace inverse of 1 over s raised to the power of 0 is equal to t raised to the power of, now n is equal to 0, so this is going to be 0 minus 1 divided by gamma of 0. Now there is a result in gamma function. In fact, we can show this result that let me write down, this is a result in gamma function, which is gamma of 0 is equal to infinity. In fact, we can prove this. Probably when we are doing the course on special functions, I will show you how exactly we can prove gamma of 0 is equal to infinity. For now, it is sufficient that we use this result, that gamma of 0 is infinity. So having presented this result, this is going to be, I got 0 negative 1, so this is going to be t raised to the power of negative 1 in the numerator divided by gamma of 0 is infinity. Now whenever you have infinity in the denominator, infinity is a large value, so naturally this is going to be equal to 0. Now on the left side you have Laplace inverse of s raised to the power of 0, that's going to be 1. So that means you have Laplace inverse of 1 to be equal to 0. So hence proved. So I can state here hence proved. Of course, if they ask you this to prove, then this is how you go about. If you have to just use this result, then it's fine. Just use this result, Laplace inverse of 1 is equal to 0 in the problems. So we got this question, students. We are expected to find the Laplace inverse of 1 over s positive 2 raised to the power of 2 positive 25. Now I can rewrite this as Laplace inverse of 1 over s positive 2 raised to the power of 2 positive 5 squared. Now just observe this, there is a shift that is present here, so I want to remove that shift, and the shift is s positive 2. So if you want to remove that shift, you will have to place e raised to the power of negative 2t. followed by Laplace inverse of, now the shift is removed, so s stands alone, and place that s there. So since the degree is 2, it's going to be s squared followed by 5 squared. So now what is this? This is nothing but Laplace inverse of sine component, right? So we know that Laplace inverse of, let me write that down, sine at is equal to a over s squared positive a squared. But what is Laplace transform of sine 5t? So that's going to be 5 over s squared positive 5 squared. But we don't have a 5 there, so we need to push the 5 down. So this is going to be 1, if I were to obtain the Laplace inverse, so this is going to be 1 over 5 times sine 5t is equal to Laplace inverse of 1 over s squared positive 5 squared. So this is just to make you understand what is exactly happening. So this is equal to e raised to the power of negative 2t, and I need to just place 1 over 5 times sine 5t. Of course I can rewrite this as e raised to the power of negative 2t divided by 5 times sine 5t. So this is the solution to this question. So let's do this question. Laplace inverse of 1 over s negative 4 raised to the power of 2 positive 36. I'm going to rewrite this as Laplace inverse of 1 over s negative 4 raised to the power of 2 positive 6 squared. Now clearly you can see that a shift of s negative 4 is taking. So if you want to get rid of this shift, you need to place e raised to the power of, this is s negative 4, so this should be e raised to the power of 4t times Laplace inverse of 1 over s squared positive 6 squared. So by now you should be able to recognize that this is nothing but sine 6t. Since there is no constant of 6 involved there, you will have to multiply it with 1 over 6 followed by e raised to the power of 4t. So if you want to rewrite this, this is going to be e raised to the power of 4t over 6 times sine 6t. So this is going to be my Laplace inverse of 1 over s negative 4 the whole square positive 36. So that's the solution to this question, students. So we got two questions. We are expected to find the Laplace inverse of 1 over s positive 3 raised to the power of 2 negative 9. Now clearly I see that there is a shift of s positive 3 taking place, so I want to get rid of this shift. So this is going to be e raised to the power of negative 3 times t times L inverse of 1 over s squared positive 3 squared. It's negative 3 squared, right? So now this is similar to our Laplace transform for hyperbolic sine. So I can rewrite this as e raised to the power of negative 3t. So this is going to be my shin 3t. 3 is a constant, so I can just multiply it by 3 and rewrite this as e raised to the power of negative 3t divided by 3 times shin 3t. So that's a solution for this question. Now coming to the question number 2, we are expected to find the Laplace inverse of 1 over s negative 5 raised to the power of 2 negative 16. I can clearly see that there is a shift of s negative 5 taking place. So to get rid of the shift, I need to place e raised to the power of positive 5 times t times L inverse of 1 over s squared. 16 is going to be 4 squared. This is nothing but hyperbolic shin. So I can rewrite this as e raised to the power of 5t. This is shin 4t. So all you need to do is just place shin 4t, and I need to multiply by 1 over 4. Rewriting, this is going to be e raised to the power of 5t divided by 4 times shin 4t. So that is the solution for this question. Students, we are given this question. We are expected to find the Laplace inverse of s over s positive 2 raised to the power of 2 positive 25. So this is a little bit different. I know you would be thinking, let us apply the shift and connect it with the Laplace transform of cos. but it doesn't work that way. If you were to see the denominator, yes, shift is taking place from s to s positive 2, but in the numerator there is no sign of the shift taking place. So what we have to do to solve this question, we will have to apply the shift. In other words, make sure that the shift is also reflected in the numerator. So how do I do that? I rewrite the numerator, which is s here, as s positive 2. That is the shift here. So I added a positive 2, so I'll have to get rid of that 2. So that's why I'm placing the negative 2 there, divided by s positive 2 raised to the power of 2 positive 25. I'm going to rewrite it as 5 squared. Now from algebra, if I were to have a positive b divided by some c, I can rewrite it as a over c positive b over c. This is always possible. So I would like to club these two together and write it as Laplace inverse of s positive 2 divided by s positive 2 raised to the power of 2 positive 5 squared, and the other quantity negative 2 of s positive 2 raised to the power of 2 positive 5 squared. Now Laplace inverse is closed under linear property, so that would mean Laplace inverse of a positive b will be same as Laplace inverse of a positive Laplace inverse of b. So by this linear property, I can rewrite this as Laplace inverse of s positive 2 divided by s positive 2 raised to the power 2 positive 5 squared negative, I can bring the 2 out, so Laplace inverse of 1 over s positive 2 whole squared positive 5 squared. Now this can now be applied. In other words, I can get rid of this shift here because the shift occurs in the numerator as well as in the denominator. So this is going to be e raised to the power of negative 2 times t Laplace inverse of s over s squared positive 5 squared negative 2 times Laplace inverse, again the shift e raised to the power of negative 2t Laplace inverse of 1 over s squared positive 5 squared, okay, 5 squared. So this is going to be, I'm using this space here, this is going to be equal to e raised to the power of negative 2t. Now s over s squared positive 5 squared, that's going to be cos 5t negative 2 times e raised to the power of negative 2t. Now 1 over s squared positive 5 squared, that's going to be sine 5 times t, constant is 5, so we divide by that. So if I were to take e raised to the power of negative 2t out, I would get cos 5t negative 2 over 5 times sine 5t. So this is the final answer to this question, students. Students, we are expected to find the Laplace inverse of s over s negative 3 raised to the power of 2 negative 81. Now clearly there is a shift that is taking place, but apparently that shift is not visible in the numerator. So what we have to do is we will have to convert the numerator to represent this shift. So that is exactly what I'm going to do. So I'm going to rewrite this as Laplace inverse of. Now I would place add a negative 3 and remove that 3 out. So this is what I'm doing. So apparently there isn't any change at all with this particular action. Now coming to the denominator, you got s negative 3 raised to the power of 2, and this 81, I can always write 81 as 9 squared. Now what I wish to do is I would like to club s negative 3 together and rewrite this entire thing as Laplace inverse of. Now algebraically, if you have something like this, a positive b or a negative b over c, I can rewrite this as a over c positive b over c. So this is always possible. So that is exactly what I'm going to do. I'm going to rewrite this as s negative 3 divided by s negative 3 raised to the power of 2 negative 9 squared. So this is one term. Now followed by my next term is going to be 3 divided by s negative 3 raised to the power of 2 negative 9 squared. So this is what I've got. Now, by linear property present in inverse Laplace transformation, I can state that by linear property, I can rewrite this as Laplace inverse of s negative 3 divided by s negative 3 raised to the power of 2 negative 9 squared. This is one term, followed by, I'm actually taking L inverse inside, so it's going to be L inverse of 3 over s negative 3 raised to the power of 2 negative 9 squared. So this is what I've got. Now the shift is negative 3, so I want to get rid of that. So that would mean this is going to be e raised to the power of negative, so it's going to be positive here, positive 3t, and Laplace inverse of s divided by s squared negative 9 squared, followed by the same thing. I'm getting rid of the shift, so it's going to be e raised to the power of 3t, and L inverse of s over s squared negative 9 squared. Now, what is this exactly? Do you remember? Now let me write that down. We know that Laplace inverse of s over s squared negative a squared is cos at, or hyperbolic cos. Okay, we got this formula. So by this formula, I can rewrite this as e raised to the power of 3t. Laplace inverse of this is going to be giving me cos a is 9, cos 90, positive e raised to the power of 3t. Now this again is going to be, this is actually 3. It's not, it is not, I've just placed it as s. It shouldn't be s. This is actually 3, right? So now for this we got to use another formula. So we know that, so let me write that down. So we know that Laplace inverse of 3 over s squared negative 9 squared. In fact, I want to use the formula concerned with the constant. So Laplace inverse of 1 over, say, s squared negative a squared, so is equal to 1 over a times shin at. So this is a formula that we have already got, right? Now using this formula, if I were to have just the constant, so what I can do is I can just take this constant out and write this as Laplace inverse of, this is going to be 1 over s squared negative 9 squared. So I can just convert this into this fashion. So that's exactly what I'm doing. So I would rewrite this as 3 times L inverse of 1 over s squared negative 9 squared, and then use the equivalence of this over here. So if I were to do that, let me rewrite this. This is e raised to the power of 3t times hyperbolic cos 9t, positive 3 times e raised to the power of 3t. So this is going to be 1 over a shin at, right? So this is going to be, in place of a I've got 9, and that's going to be shin 90. So rewriting, this is equal to e raised to the power of 3t cos 90. 3 divides here 3 times, so this is e raised to the power of 3t divided by 3 shin 90. Now I can take e raised to the power of 3t out and rewrite this as cos 90 positive 1 over 3 times shin 90. So this is the solution to the question. Students, we got 2 questions. I would like you all to try these 2 questions. Probably you can just pause the video and get the solution, and then check the solution with the solution that is obtained over here. Okay, so I believe you have solved this successfully. So let us get the solution for this question. Now Laplace inverse of 1 over s positive 5 raised to the power of 4. There is a shift of s positive 5. Now to neutralize the shift, I will have to rewrite this as e raised to the power of it. So this is going to be, it's positive 5 there, so this is going to be e raised to the power of negative 5 times t, Laplace inverse of 1 over s to the power of 4. So this is what I've got. Now we know that the Laplace inverse of 1 over s to the power of n is equal to t raised to the power of n negative 1 divided by n negative 1 factorial. So we got this formula. Of course, you can either use this formula or the other one which I've showed you. So this would mean Laplace inverse of 1 over s to the power of 4 is equal to t raised to the power of 4 negative 1, 3 divided by 3 factorial, which can further rewritten as t raised to the power of 3 divided by 3 factorial is 6. So in place of this, I need to place this. So these are all for your understanding. So hence directly you can rewrite this is equal to e raised to the power of negative 5t times L inverse of 1 over s to the power of 4 is t to the power of 3 divided by 6. So this is the final answer. So coming back to the question over here, clearly we see that there is a shift of s negative 6. So this is going to be e raised to the power of positive 6 times t, Laplace inverse of 1 over s raised to the power of 7. Now we know that Laplace inverse of 1 over s to the power of n is t raised to the power of n negative 1 divided by n negative 1 factorial. So directly I can write this as t raised to the power of 6 divided by 6 factorial, and this can be rewritten as e raised to the power of 60 times t raised to the power of 6. 6 factorial is 720. So this is going to be the solution for this question. Students, let's do this question. We are expected to find the Laplace inverse of s divided by s positive 5, with the degree being 5 there. Now there is a shift that is taking place. It's clearly visible in the denominator, but it is not reflected in the numerator. So we will have to bring that shift to the numerator also. So I'm going to rewrite this as Laplace inverse of is positive 5. So let me place positive 5 there and remove that 5 out. And then this is divided by s positive 5 raised to the power of 5. So this is what I've got. Now I'm going to rewrite this by clubbing these two terms together. I'm going to say Laplace inverse of s positive 5 divided by s positive 5 raised to the power of 5. This is one term, and followed by another term, 5 divided by s positive 5 raised to the power of 5. So this is what I've got. Now by linear property present in inverse Laplace transformation, I can rewrite this as L inverse of s positive 5 divided by s positive 5 raised to the power of 5, followed by negative L inverse of 5 divided by s positive 5 raised to the power of 5. Students, we are given this question, L inverse of s over s positive 6 raised to the power of 7. Now I can see a shift being present in the denominator, but it is not reflected in the numerator. So we should ensure that the numerator is reflective of the shift that is present in the denominator. So what I wish to do is I would like to rewrite this as L inverse of, there is this positive 6 there, so I would add a 6 and remove a 6 divided by s positive 6 raised to the power of 7. So this is what I've got. Now I can club this s positive 6 together and rewrite this as L inverse of s positive 6 divided by s positive 6 raised to the power of 7. This is one component, and then followed by a negative and a 6 divided by s positive 6 raised to the power of 7. This is the second component. Now what I wish to do by linearity present in inverse Laplace transformation, I would be rewriting this as L inverse of s positive 6 divided by s positive 6 raised to the power of 7. This is one term followed by a negative sign, and L inverse of 6 divided by s positive 6 raised to the power of 7. Now clearly I can cancel one of these and rewrite this again. Make sure to rewrite it. Don't just carry on with any other simplification without rewriting it, because it would create some confusion or you would even miss a term. So this is going to be 1 over s positive 6. The degree is 6 here because we have cancelled, followed by L inverse of 6 divided by s positive 6 raised to the power of 7. Now I want to get rid of this shift, so this is going to be e raised to the power of positive 6 is going to be negative 6 times t, L inverse of 1 over s raised to the power of 6. And clearly, in fact, I could have taken the 6 out. So let me take the 6 out and have one more step. This is going to be 6 times L inverse of 1 over s positive 6 raised to the power of 7. In fact, this is going to be e raised to the power of negative 6t, L inverse of 1 over s to the power of 6. Negative 6 times, so we apply the shift. This is e raised to the power of negative 6 times t, L inverse of 1 over s raised to the power of 7. Now we know that Laplace inverse of 1 over s raised to the power of n is equal to t raised to the power of n negative 1 divided by n negative 1 factorial. This formula is well known. So by this formula, this is e raised to the power of negative 6 times t. Laplace inverse of 1 over s raised to the power of 6 is going to be t raised to the power of 5 divided by 5 factorial, negative 6 times e raised to the power of negative 6t, t raised to the power of 6 divided by 6 factorial. Now I see a e raised to the power of negative 6t common. I can take that out, and t power 5, t power 6, I can take t power 5 out and rewrite this as 1 over 5 factorial negative 6 times, I have a t, and then this is 6 factorial, so probably I place the 6 factorial there. Now 6 over 6 factorial, so let me just show that to you. 6 over 6 factorial can be written as 6 over, this can be rewritten as 6 times 5 factorial. So 6 and 6 can be cancelled, giving me 1 over 5 factorial. So that is exactly what I'm going to do. So this is equal to e raised to the power of negative 6t, t raised to the power of 5 of 1 over 5 factorial negative t over 5 factorial. Now you can clearly see even 5 factorial is common, so I can take that out. So this is going to be e raised to the power of negative 6t, t raised to the power of 5 divided by 5 factorial of 1 negative t. So this is the solution that we've got. Of course, if you want to write 5 factorial as 120, you can write that. So this is going to be e raised to the power of negative 6 times t, t raised to the power of 5 divided by 120 of 1 negative t. So this is the final solution for this question. I know that I have taken a few steps in addition, but sometimes it's better to present those steps for ensuring a better understandability. So we move on to the next question, students. So we given this question, students, Laplace inverse of s positive 7 divided by s positive 3 squared positive 16. I would like to request you all to pause the video and make an attempt for a few minutes. Okay, so now that you have achieved the solution for this question, let us see if your solution agrees with the one that's shown here. Now you got s positive 7 here and you have a 3 here, so definitely there is a shift that is taking place which is visible in the denominator, but it isn't reflected in the numerator. So what I wish to do, I would like to rewrite this as Laplace inverse of s with positive 3. So I want to split 7 as 3 and 4, and then the denominator s positive 3 raised to the power of 2 positive 16 I can rewrite it as 4 squared. I can further group them and split them as L inverse of S positive 3 divided by S positive 3 raised to the power of 2 positive 4 squared. This is one term, followed by 4 over S positive 3 raised to the power of 2 positive 4 squared. This is the next term. By linear property available in inverse Laplace transformation, I can rewrite this as L inverse of S positive 3 divided by S positive 3 raised to the power of 2 positive 4 squared, and this is L inverse of 4 over S positive 3 raised to the power of 2 positive 4 squared. Now I can see that there is a shift that is taking place here, so I'm going to rewrite this as e raised to the power of negative 3 times t L inverse of, this is going to give me S divided by S squared positive 4 squared for this term, and the 4 can always be moved out. So moving the 4 out, I prefer to write one more step just for sake of understanding. So I'm taking the 4 out, and this is going to be L inverse of 1 over S positive 3 raised to the power of 2 positive 4 squared. Of course, we can apply the shift now. This is going to be e raised to the power of positive 3, so it's going to be negative 3 times t, and L inverse of 1 over S squared positive 4 squared. I will repeat the step. This is e raised to the power of negative 3t L inverse of S over S squared positive 4 squared. Now this one is going to be 4 times e raised to the power of negative 3t. This is going to be sine 4 squared, so 4t with a multiple of 1 over 4. That's what we are going to get here. And this is going to be e raised to the power of negative 3t. Now Laplace transform of cos at is s over s squared plus a squared, right? So therefore Laplace transform of cos 4t is going to be s over s squared plus 4 squared, just for your understanding. So this is going to give me cos 4t. Now the 4 that you see here can be cancelled, so that is going to give me e raised to the power of negative 3t cos 4t positive e raised to the power of negative 3t and sine 4t. I can take e raised to the power of negative 3t out and write this as cos 4t positive sine 4t. So this is the solution to this question. Students, we are given this question. We are expected to find the Laplace inverse of 3s positive 7 divided by s positive 4 raised to the power of 2 positive 25. Now observation 1, always, this is imperative, always the coefficient of s should be equal to 1. If it is not, then we will have to achieve that. So having mentioned this, I've got a 3 as a coefficient of s, so I need to get rid of that. So I'll start off by writing L inverse of, I'm taking 3 out. If I were to take 3 out, I would get s positive 7 over 3. This is what I'm getting. Divided by s positive 4 raised to the power of 2 positive 25. Now I can take 3 out by linear property, in fact by the property of inverse Laplace transformation. Now I'm going to rewrite this as 3 times of L inverse of s positive 7 over 3 divided by s positive 4 raised to the power of 2 positive 25. So I've got this. Now clearly I can see that there is a shift that is taking place in the denominator that has to be reflected in the numerator. So I would like to achieve that. So it's going to be rewritten as 3 times L inverse of S positive 4 and minus 4 followed by 7 over 3 divided by S positive 4 raised to the power of 2 positive 25. Now I'm going to club these two together and club these two together and rewrite this as 3 times of L inverse of S positive 4 divided by S positive 4 raised to the power of 2 positive 25. So this is one term followed by positive sign and a negative 4 added with 7 over 3 divided by S positive 4 raised to the power of 2 positive 25. So this is what I've got. Now let me show you what happens when you add negative 4 with 7 over 3. This is going to give me negative 12 added with 7 divided by 3, which is negative 5 over 3. So I need to have a negative 5 over 3 in the numerator. So this is rewritten as 3 times of L inverse. Now I can use the linear property present in inverse Laplace transformation and write this as L inverse of S positive 4 divided by S positive 4 raised to the power of 2 positive 25. So this is one quantity positive L inverse of, this is negative 5 over 3, so let me place that negative 5 over 3 divided by S positive 4 raised to the power of 2 positive 25. Now before I could apply the shift, I want to take this constant out. So if I take this constant out, I will get negative 5 over 3 L inverse of 1 over S positive 4 raised to the power of 2 positive 5 squared. I'm rewriting it like this. And this is going to be L inverse of S positive 4 divided by S positive 4 raised to the power of 2 positive 5 squared. So that's fair enough. So this negative sign is in between. Now I am going to get rid of the shift. So that is going to give me e raised to the power of negative 4 times t L inverse of S over S squared positive 5 squared. That's one term followed by negative 5 over 3. Shift is negative 40 there, e raised to the power negative 40 times L inverse of 1 over S squared positive 5 squared. Now this can be further rewritten as 3 times e raised to the power of negative 4 times t. Now Laplace inverse of S over S squared positive 5 squared is going to be cos of 5 times t. This is negative 5 over 3 times e raised to the power of negative 4t. This is S squared positive 5 squared. That's Laplace inverse of 1 over S squared positive 5 squared. That's going to be sine 5t times 1 over 5. So this is what I've got. Now the 5 that you see here and the 1 that you see here can be cancelled. And if I were to take this 3 inside, this is going to be 3 times e raised to the power of negative 4t times cos 5t, and 3 can be cancelled. So that would give me negative e raised to the power of negative 4t times sine 5t. Now this is what I've got. Now if you want, you can take this e raised to the power of negative 4t out. So that would give me 3 times cos 5t negative sine 5t. So this is the solution for this question. Students, we are given this question. We are expected to find the Laplace inverse of 1 over s positive 5. Probably I'll change this to 8 because I already have a question of that magnitude. So let us just see how to do this question. Now, the first observation that you will have to see here is the power exponent given here is of fractional nature. So that is a very important observation. So far we have dealt with questions which add an integer power. When I say integer, the value of n ranges from 0 onwards, so it's positive values, right? 1, 2, 3 and so on. Of course, the best way to say the values of n, in other words the values of the exponent, started from 0. N starts from 0 and it takes values 1, 2, 3, 4 and so on and so forth. But in this case, the exponent value is fractional in nature. So how are we going to do a situation, or how are we going to do a question of this nature? So what I wish to do is, first, clearly I can see that I can apply shift here. So I can get rid of this s positive 8 by rewriting this as e raised to the power of negative 8 times t Laplace inverse of 1 over s raised to the power of 5 over 2. So this is what I've got. Now we know that Laplace inverse of 1 over s raised to the power of n, when a fractional quantity is involved in the exponent, this is going to be t raised to the power of n negative 1 divided by gamma of n. This is the formula that we will have to use. So by this formula I can rewrite this to be as e raised to the power of negative 8 times t raised to the power of, this is going to be 5 over 2 negative 1 divided by gamma of 5 over 2. Now what do we get here? This is equal to e raised to the power of negative 8t times 5 over 2 negative 1. That's going to be t raised to the power of 3 over 2 divided by gamma of 5 over 2. Now gamma of 5 over 2, how do we calculate? We start off by subtracting a 1 here. So that would be giving me 3 over 2. Subtract 1, that's going to give you 1 over 2. The minute you reach 1 over 2, place a gamma of 1 over 2. Now you have to know that gamma of 1 over 2 is root of pi. So using that value of gamma 1 over 2, I can rewrite this as 3 over 2 times 2 is 4. Gamma 1 over 2 is root pi. So place that value, root of pi. So this is how we evaluate gamma of 5 over 2. So that is going to be equal to e raised to the power of negative 8 times t raised to the power of 3 over 2 divided by 3 over 4 root of pi. Now if you were to flip this, this could be rewritten as 4 times e raised to the power of negative 8t. Now you got t raised to the power of 3 over 2. Now I can rewrite this as t raised to the power of 3, and that is raised to the power of 1 over 2 by the law of indices. So this is going to be root of t raised to the power of 3. Right? By the law of indices it's possible. Why is it possible? Because a raised to the power of m over n can be written as a raised to the power of m, the whole raised to the power of 1 over n. So that's exactly what I have done. So if I were to rewrite this, so this is going to, 4 is going to be going to the numerator, followed by e raised to the power of negative 8t, and t raised to the power of 3 over 2 is going to be root of t cubed divided by, there is a 3 there and there is a pi there. Of course you can further rewrite this as 4 over 3 times e raised to the power of negative 8t times root of t cubed divided by pi. So that will be the solution for the question. Of course you don't have to come down all the way up to here, but if in case this question is asked in MCQ, and this is the choice that is given, then you will have to reduce and simplify up onto the choice that is reflective of the outcome that is required. Thank you, students. We'll move on to the next question. Students, we are given this question. We are expected to find the Laplace inverse of s over s negative 3 raised to the power of 7 over 2. Now, if you would kindly see the question which I just did a minute ago, you can see that the numerator hasn't got any s present there. But in this case, you have a presence of a s. So this problem is different from the previous one. And also you have an exponent of 7 over 2, which is fractional in nature. Clearly I can see that there is a shift that is present here in the denominator, but that shift has to be reflected in the numerator. So for that, I'm going to rewrite this as L inverse of, I'm going to place a negative 3 and I'm going to get rid of that same negative 3 by placing a positive 3. So that has to be divided by s negative 3 raised to the power of 7 over 2. I can club these two together and then I can rewrite this as L inverse of s negative 3 divided by s negative 3 raised to the power of 7 over 2, followed by positive 3 over s negative 3 raised to the power of 7 over 2. So this is what I've got. Now, by linear property present in inverse Laplace transformation, I am going to rewrite this quantity as L inverse of s negative 3 divided by s negative 3 raised to the power of 7 over 2. Positive L inverse of, the 3 can be brought out, so I'm going to place it like this, 1 over s negative 3 raised to the power of 7 over 2. Now just observe this, you got a s negative 3 and s negative 3 raised to the power of 7 over 2. Now I would like to bring this down. If I were to bring this down, I would be encountering something of this fashion, 1 over s negative 3 raised to the power of 7 over 2. I'm bringing it down, so it's going to be s negative 3 raised to the power of negative 1. So this is actually 7 over 2 negative 1. That would give me 5 over 2. So if I were to write this completely, this is going to be s negative 3 raised to the power of 5 over 2. Right? So let's do that. So let me write that down here. This is equal to L inverse of 1 over s negative 3, right, raised to the power of 5 over 2 positive 3 times L inverse of 1 over s negative 3 raised to the power of 7 over 2. Now, by applying the shifting theorem, I can clearly get rid of this. This is going to be e raised to the power of 3 times t, L inverse of 1 over s raised to the power of 5 over 2, followed by 3 times of e raised to the power of positive 3t times L inverse of 1 over s raised to the power of 7 over 2. So this is what I've got. Now, by applying the formula which we have already studied, this can be rewritten as e raised to the power of 3t, and this is t raised to the power of 5 over 2 divided by, in fact followed by a negative sign, divided by gamma, it's going to be gamma of n. So it's going to be gamma of 5 over 2. So that's what we are going to encounter with. And this is going to be 3 times e raised to the power of 3t, 7 over 2, that's going to be t raised to the power of 7 over 2 negative 1, divided by gamma of 7 over 2. Now gamma of 5 over 2 I've already found out. So let me draw your attention to that. This is gamma of 5 over 2, which is 3 over 4 times root pi. So I'm going to rewrite that as e raised to the power of 3t. Now this is going to be t raised to the power of 5 over 2 negative 1. That's going to give me 3 over 2 divided by 3 times root of pi, and I get a 4 there. I can flip it. If I were to flip it, it will go to the numerator like this, followed by positive 3 times e raised to the power of 3t. Now this is going to give me 5 over 2, 7 over 2 minus 1. That's going to be 5 over 2. And gamma of 7 over 2, we can find that out. I'm going to show you that, how to get gamma of 7 over 2. Let me use this space here. So I get gamma of 7 over 2. I start off by reducing a 1 from here. So it's going to be 5 over 2. I reduce a 1, that's going to be 3 over 2. I reduce a 1, I get 1 over 2. Place gamma of 1 over 2. This is going to be 5 times 3, 15. 2 times 2, 4. 4 times 2 is 8. Times gamma of 1 over 2 is going to be root of pi. So this is actually 15 times root of pi divided by 8. What is that? That's nothing but gamma of 7 over 2. So 15 root pi, so I need to place that here. So this is going to be 15 root of pi, right? And divided by 8. So I can flip that 8. 8 goes here, and there is a 3 here. 3 times 8 is 24. So I can have that 24 there. Okay, so this is what we have got. Of course, we can take things common out and simplify and give the result. So let me just try showing you that. So I get a e raised to the power of 3t, and then I can substitute that and place that e raised to the power of 3t, and 24 and 4 I can take 4 out, and I have a pi, root pi here, so I can also have a root pi there. I have a t raised to the power of 3 over 2 and a t raised to the power of 5 over 2. So that means t raised to the power of 3 over 2 can be taken out. So if I were to take out this would give me 1 over 3, and this is going to give me 6, because 4 times 24, 6, and then I will have to have t raised to the power of 5 over 2. So that is possible only if I have a t there, right? Because that would give me, but I need a 15 there, so this is going to be 15 placed there. In fact, you can clearly see that I could have taken the 3 out also. So this is how it works, but in fact we can still do some reductions. So you have a 6 and a 15, so the reduction is still possible. Anyway, I leave it to the audience to reduce it further and simplify. But as far as solution is concerned, this is a good place to stop, or further down you want to make simplification, you can do so. Thank you, students. We'll move on to the next question. Students, we're given this question. We expected to find the Laplace inverse of 3s positive 5 divided by s negative 4 raised to the power of 3 over 2. So if you would remember, previously I have stated the coefficient of s should always be 1. So in this case we see that the coefficient of s is 3. So we got to get rid of that. So I'm going to rewrite this as Laplace inverse of. So I'm going to take the 3 out. So that would mean I get s positive 5 divided by s negative 4 raised to the power of 3 over 2. Now I can take this constant 3 out. So if I were to do that, this is going to be Laplace inverse of s positive 5 divided by s negative 4 raised to the power of 3 over 2. So this is what I've got. Now I can see a presence of a shift there, but the numerator is not reflective of the fact that there is a shift present in the denominator. So I will have to get that into the numerator. So for that, what I would do is I would just place, or I would say add a -4 and subtract a -4. So that's going to be in this fashion. So in other words, I'm not doing anything. I'm just retaining the numerator as it is. But in the latent side, we are performing some manipulation, or I would say there is something going on in the numerator. So this has to be divided by s -4 raised to the power of 3/2. So this is what we have got. Now I would be clubbing these two together, and of course I don't have to club it because that is the only eventuality that is present here. So this is equal to 3 times L inverse of, so I got s -4 divided by s -4 raised to the power of 3/2. Positive 4 added with 5 will give me 9 divided by s -4 raised to the power of 3/2. Now, by the linearity available in inverse Laplace transformation, I can rewrite this as 3 times of L inverse of s -4 divided by s -4 raised to the power of 3/2. This is one term followed by L inverse of 9 over s -4 raised to the power of 3/2. This is the next term. Now this is actually, I need to cancel this term, right? So this is 3/2. So when I bring it down, this is going to have a negative exponent. That's going to be -1. So if I were to take the LCM, I would get 3 -2, which is equal to 1/2. That's a value that I would be getting here. So that is equal to 3 times of Laplace inverse of 1 divided by s -4. This is raised to the power of 1/2. So that's exactly, I need to place 1/2 followed by plus, I can take the 9 out, and that's going to be Laplace inverse of 1 over s -4 raised to the power of 3/2. So this is what I've got. Now I can apply the shift now. So this is going to give me e raised to the power of positive 4 times t, Laplace inverse of 1 over, in fact let me write that down, s raised to the power of 1/2 positive 9 times e raised to the power of 4t, Laplace inverse of 1 over s raised to the power of 3/2. Okay, so now I can apply the formula. L inverse of 1 over s raised to the power of n is equal to t raised to the power of n -1 divided by gamma of n. Why do I use this formula? Because of n being fractional in nature. So this is equal to 3 times of e raised to the power of 4 times t raised to the power of n, that's 1/2 -1 divided by gamma of 1/2 positive 9 times e raised to the power of 4 times t, and this is t raised to the power of 3/2 -1 divided by gamma of 3 over 2. So this is what I've got. Now gamma of 1 over 2 I know. So gamma of 3 over 2 is, I start off by subtracting 1. So that's going to be 1 over 2. The minute you see 1 over 2, place a gamma of 1 over 2. So this is going to be 1 over 2. Gamma of 1 over 2 is root of pi. So that is the value for gamma of 3 over 2. So this is equal to 3 times of e raised to the power of 40 times of negative 1. That will give you negative 1 over 2 divided by root of pi positive 9 times e raised to the power of 4 times t. This will give you t raised to the power of positive of divided by gamma of 3 over 2 is going to be 1 over 2 times root of pi. Now I can rewrite this as 3 times. Now e raised to the power of 4t, I can take it out, and I've got a t raised to the power of 1 over 2, and I just want to keep it within the parenthesis, but there is a root pi, so I can take that root pi out, and this is going to be t raised to the power of negative 1 over 2. In fact, if okay, let me just retain it. So it's going to be positive 9 times t raised to the power of positive of, there's 1 over 2. When I flip it, I can have a 2 there, so that would mean I will have a 18 here. So I would change this. 9 times 2 is 18, so let me just place it like that. Now I can rewrite this as 3 times e raised to the power of 40 divided by root of pi times t raised to the power of negative of is 1 over root of t positive 18 times root of t. So this is a nice result that we have got. Students, we are given these 2 questions. I would like you all to try these 2 questions, and you can pause the video and provide me with the solution. If you're finished, we can check our solutions with the one that is presented here. So let's start off with question number 2, and then we will go on to question number 1. So we are given L inverse, we are asked to find L inverse of 1 over root of s positive 3. Step number 1, rewrite this as L inverse of 1 over s positive 3 raised to the power of half. And next you apply the shift, that's going to be e raised to the power of negative 3t, giving you L inverse of 1 over s raised to the power of 1 over 2. Now we know this formula, that L inverse of 1 over s raised to the power of n is equal to t raised to the power of n negative 1 divided by gamma of n. So we would be using this formula. This would be equal to e raised to the power of negative 3t, t raised to the power of n, that's 1 over 2 negative 1 divided by gamma of 1 over 2. This is equal to e raised to the power of negative 3t. 1 over 2 negative 1 will give you negative 1 over 2. Gamma of 1 over 2 is root of pi. I can rewrite this as e raised to the power of negative 3t. Moving t down, I get t raised to the power of 1 over 2 times root of pi. This can be further rewritten as e raised to the power of negative 3t divided by root of pi times t. So this is a beautiful solution you can have. And let us move on to question number 1. So we are given to find L inverse of 1 over third root of S positive 4. Now foremost, this has to be rewritten as L inverse of 1 over third root. So it's going to be S positive 4 raised to the power of 1 over 3. Now if I were to apply the shift, this is going to be e raised to the power of negative 4 times t, and L inverse of 1 over S raised to the power of 1 over 3. Now by using the formula, we know this formula, which is 1 over Laplace inverse of 1 over S power n is t raised to the power n minus 1 divided by gamma of n. So by that formula, this is going to be e raised to the power of negative 4t, t raised to the power of 1 over 3 negative 1 divided by gamma of 1 over 3. Don't try to attempt to find the value of gamma of 1 over 3, because I have not taught you how to find this out, because that's a special topic, or in other words a different subject altogether. It comes under the subject called the special functions, which I will be discussing in detail in another class. For now, just retain gamma of 1 over 3 as it is, because this expectation of the subject doesn't require you to evaluate gamma of 1 over 3. So it's okay that we can have it as gamma of 1 over 3. So having mentioned this, let me rewrite this as e raised to the power of negative 4 times t. This is going to be 1 over 3 negative 1. I take the LCM as 3. 1 negative 3, which is negative 2 over 3. So it's better to calculate the exponent, because we don't want to make any mistakes there. So this is going to be t raised to the power of negative 2 over 3 divided by gamma of 1 over 3. I can push this down, and that would be e raised to the power of negative 4t divided by gamma of 1 over 3 times t raised to the power of 2 over 3. Now this is further, you can simplify it if you want, e raised to the power of negative 4t divided by gamma of 1 over 3. Now I can rewrite this as t squared of 1 over 3, and that is further rewritten as e raised to the power of negative 4t divided by gamma of 1 over 3 times third root of t squared. Okay, so this is the solution. Sometimes it becomes imperative that we go all the way to the end because of the requirements for the question as well as for the content, to provide a better understanding. So thank you students, we will move on to the next question. Students, we are given this question. We are expected to find the Laplace inverse of s positive 7 divided by s squared negative 6x positive 11. Now foremost, what I would like to do is I would like to rewrite the denominator as a perfect square. In fact, I would use the technique of completing the square in achieving my objective. So this is, I'm taking it to be equal to 0, so I can move this to the other side. So that would be negative 11. Now I get a coefficient of s to be as negative 6. So what you need to do is divide by 2. You get negative 3. Now all we need to do is to add negative 3 squared to this quantity on the left side. So actually we got s squared negative 6s, right? So just add negative 3 squared on both sides. So this is going to be negative 3 squared. Now this can be rewritten as s negative 3 raised to the power of 2. Now if you were to expand this, you would get s squared negative 6s positive 9, right? So that's fair enough. On the right hand side, it's negative 11 positive 9, which is going to be 9 added with negative 11. That would give me negative 2 there. So what have I achieved? I have achieved s squared
negative 6s positive 11 to be rewritten as s negative 3 raised to the power of 2. Negative 2, if I were to move it to the other side, I will get positive 2. So this is what I have achieved. Now why did I do that? So that this would help me to solve the question. Now you don't have to adopt this way of expanding or expressing the component s squared negative 6s positive 11 as a completing square. You're free to choose the way that you like. Now I have chosen this. Now if I were to expand this, this is s squared negative 6s positive 9 positive 2, which is nothing but the left hand side quantity. Go back to the question. So this is going to be Laplace inverse of s positive 7 divided by s negative 3 raised to the power of 2 positive 2. So this is what I have got. So clearly I am actually representing the denominator as a shift. Now this can be further rewritten as, now I want to have the shift in the numerator, so I'm going to add a negative 3 and subtract that same negative 3, followed by 7 divided by s negative 3 raised to the power of 2 positive 2. Now I'm going to group these two things together, so this would give me L inverse of s negative 3 divided by s negative 3 raised to the power of 2 positive 2, and 7 or 3 added with 7 will give me 10. So this is what I've got. Now I can further rewrite this as L inverse of s negative 3 divided by s negative 3 raised to the power of 2 positive 2, followed by 10 divided by s negative 3 raised to the power of 2 positive 2. By linear property, I can rewrite this as L inverse of s negative 3 divided by s negative 3 raised to the power of 2 positive 2. This is one component, positive L inverse of 10 divided by s negative 3 raised to the power of 2 positive 2. This is the second component. In fact, I could have taken 10 outside. So let me place 10 outside and rewrite this as 1. So this is what I've got. Now I can apply the shift here. So if I were to apply the shift here, this would give me e raised to the power of 3t L inverse of s divided by s squared positive. Now this is 2, right? So I can rewrite it as root of 2 squared, followed by positive 10, and this is e raised to the power of negative, in fact it's s negative, so it's going to be positive 3t, and L inverse of 1 over s squared positive root of 2 squared. So this is what I've got. Now this is nothing but my cos at. So this is e raised to the power of 3t cos at. So it's going to be root of 2 times t positive 10 times e raised to the power of 3t. This is going to be my sine of root of 2 times t times root of 2. So I can take this e raised to the power of 3t out, and if I were to do this, I would get cos of root of 2 times t positive 10 over root of 2 times sine root of 2 times t. So this is my final solution for this question, students. So students, we are expected to find the Laplace inverse of s squared divided by s positive 1 raised to the power of 3. Now what I would do is I would try to express the numerator as some times square of the denominator. So that would mean I would have to try to get this s positive 1 into the numerator. So if I were to replace, instead of s positive 1 into the numerator, then I would have something like this, s positive 1 raised to the power of 2. And upon expanding, I would get s squared positive 2 times s positive 1. But this apparently has to be equal to s squared. So that would mean I would have to take away negative 2s and 1. So now my numerator
will be replaced by s squared positive 2s positive 1 negative 2s negative 1. Of course, I would not be using this. Instead, I would be rewriting it as s positive 1 raised to the power of 2 followed by negative 2s negative 1. This is the way I would use. So I can go back to the question. So therefore, Laplace inverse of s squared divided by s positive 1 raised to the power of 3 can be rewritten as L inverse of, as I mentioned to you. So let me just place this term. So it's going to be s positive 1 raised to the power of 2 negative 2 times s negative 1 divided by s positive 1 raised to the power of 3. So I would club these two things together and this particular term together. So I would rewrite this as L inverse of s positive 1 raised to the power of 2 divided by s positive 1 raised to the power of 3. That's one term. I will take a negative sign out and then rewrite this as 2 times s positive 1 divided by s positive 1 raised to the power of 3. So this is what I've got. Now by linearity, I can rewrite this as L inverse of s positive 1 raised to the power of 2 divided by s positive 1 raised to the power of 3 followed by a negative sign and L inverse of 2 times s positive 1 divided by s positive 1 raised to the power of 3. Now this one is solvable, but this one I see a shift of s positive 1, so I need to get that s positive 1 in the numerator. So how can I write 2s positive 1? So let me just substitute in place of s positive 1. So this is going to be 2 of s positive 1. If I do that, I get a 2 times s positive 2, but I need a 1, so I need to remove that by placing a negative 1. Right, so this is exactly this. So I can rewrite this as 2 times of s positive 1 negative 1. So that's exactly what I'm going to do. In place of 2s positive 1, I would be substituting this. So let's do that. So this is equal to L inverse of, now I can cancel this term, so I'll have 1 over s positive 1 for this term followed by L inverse of 2 times, in place of 2s positive 1 is going to be 2 of s positive 1 negative 1 divided by s positive 1 raised to the power of 3. Now I'm going to rewrite this as L inverse of, I'm not going to apply the inverse now as yet. So let me solve this. So it's going to be negative 2 times of, by linear property I can rewrite this as L inverse of s positive 1 divided by s positive 1 raised to the power of 3. This is one quantity and you have a negative sign, so it's going to be negative positive L inverse of 1 over s positive 1 raised to the power of 3. So this can be cancelled and I have L inverse of 1 over s positive 1 and negative 2 times L inverse of 1 over s positive 1 raised to the power of 2 and positive L inverse of 1 over s positive 1 raised to the power of 3. So this is going to be e raised to the power of negative t L inverse of 1 over s negative 2 times e raised to the power of negative t L inverse of 1 over s squared positive e raised to the power of negative t L inverse of 1 over s cubed. So this would give me, in fact I know that L inverse of 1 over s power n, this is going to give me t raised to the power of n negative 1 divided by n negative 1 factorial. Right, I can use that. So this is going to be e raised to the power of negative t and n is 1 here, so this is going to be t raised to the power of 0 divided by 0 factorial. Negative 2 times e raised to the power of negative t is going to be t divided by 1 factorial. Positive e raised to the power of negative t, this is t raised to the power of 2 divided by 2 factorial. I can rewrite it by taking e raised to the power of negative t out, and this would give me t power 0 is 1 divided by 0 factorial is 1, negative 2 times t positive t squared divided by
2 factorial is 2. So this is my final solution, students. Thank you.
Welcome students. In this class we will be learning how to handle questions which are way out of the ordinary. Now in this case we are expected to find the Laplace inverse of log of s positive 1 divided by s negative 1. Now this is unusual problem, right? This is usually they don't ask questions like this, but in competitive examinations and in graduate interviews and project interviews, they will ask questions of this nature. They will test you, specifically if you want to take up some research positions, positions or that has a scholarly bursary attached to that, then they would want to know what sort of candidates are coming in. Now for this question, what I would like to do is I would like to use the popular formula. We know that Laplace of t times f of t is equal to negative d over ds of f of s, formula that I would be using. With this formula, what I'm going to do is I'm going to now say, for example, from here you can clearly see that t times f of t is equal to L inverse of negative d over ds of f of s, right? You can clearly see that we are given to find L inverse of log of s positive 1 divided by s negative 1. So the question is, how are we going to bring in all of those things which we have seen? Foremost, what we need to do is we need to start out with this thing, with this statement. If f of t is given to be as L inverse of log of s positive 1 divided by s negative 1, if this is the situation, if I place a t on the left, this is going to be t times f of t. The moment it has a t times f of t, this has to be converted. So how does this change? So there's going to be L inverse of, we got a negative, this component is going to be negative d over ds of log of s positive 1 divided by s negative 1. This is all that you need to do. Once you place the t, this is going to become negative d over ds of this component, and you have to take the Laplace inverse of this entire thing. Now we know that log of a over b is equal to log a negative log b. We know that, right? So first this is equal to L inverse of negative d over ds of log of a over b. This is going to be log of s positive 1 negative log of s negative 1. This is what I've got. Okay, that's fine. So now this is equal to L inverse of negative. Now I would like to take the d over ds inside. So this is going to be d over ds of log of s positive 1 negative d over ds of log of s negative 1. Okay, this is fine, and this is what I got, and that should be okay. Now if y is equal to log x, okay, what is dy over dx? Dy over dx is 1 over x, right? 1 over x times differentiation of x is 1. So you have to differentiate this. So this is going to be L inverse of negative differentiation of log. In fact, I should place a parenthesis like this. So because d over ds is actually an operator operating on this component, and d over ds is operating on this. Okay, that's fine. So this is going to be 1 over s positive 1 times differentiation of s. So you don't have to write it. It's just going to be 1 followed by, in this case, it's going to be 1 over s negative 1. So that is fine. Now you got this negative sign. So if I were to, I can just take the negative sign out because by linearity. So now if I take the negative sign out, I can now bring the L inverse inside. So this is going to be L inverse of 1 over S positive 1 negative L inverse of 1 over S negative 1. Right, this is fine. Now what is this? This is actually our shifting property. So this is going to be e raised to the power of negative t. Negative, this is going to be e raised to the power of positive t. Now you will have a negative sign, so it's going to be negative e raised to the power of negative t and positive e raised to the power of t. Now what I wish to do, I wish to rewrite this as e raised to the power of t, negative e raised to the power of negative t. Now if I were to divide by 2 and multiply by 2, it's going to be 2 times of e raised to the power of positive t, negative e raised to the power of negative t divided by 2. Now what is this? What is this entire quantity? Can you tell me? This is nothing but shinty. It means that we got t times f of t is equal to 2 times shinty. But we need only f of t, right? So this would mean that f of t is equal to 2 over t times shinty. So this is the solution for the question. Students, we are given this question. We are expected to find the Laplace inverse of log of s squared positive 1 divided by s of s positive 1. So what I wish to do is, I would like to start off like this. If f of t is equal to L inverse of log of say s squared positive 1 divided by s into s positive 1, if this is the situation, then t times f of t is equal to L inverse of, this is going to be negative d over ds of log of s squared positive 1 divided by s into s positive 1. So this is what we have got. Now what I will do is, first I will take the negative sign out, and then before I could operate with d over ds, what I will do is I will use the logarithmic concept. Log of a over b is equal to log a negative log b. This is one thing we know, and then we also know log of a times b is log a plus log b. So with this, I'm going to rewrite this as log of s squared positive 1 negative log of s into s positive 1. Right? So this is what we have got. Now I further can use log of ab is equal to log a plus log b for this logarithmic component. So this is going to be negative L inverse of d over ds of log of s squared positive 1. This is fine. I'm bringing d over ds inside. So this is going to be d over ds of, this is going to be log s positive log of s positive 1. Okay, and L inverse goes for the entire term. Now if I were to differentiate differentiate log of s squared positive 1, this is going to be 1 over s squared positive 1 times differentiation of s squared positive 1. That's going to be 2 times s, followed by d over ds of log x. That's going to be 1 over s, and you get a negative sign. So negative differentiation of log of 1 over s positive 1 is going to be 1 over s positive 1. So this is what you have got. Now I can bring in the sign, but anyway I will just have the negative sign outside, and I'll rewrite this as L inverse of 2 times s divided by s squared positive 1, and L inverse of 1 over s, and then L inverse of 1 over s positive 1. Right? Now by linearity I can rewrite this as 2 times L inverse of s over s squared positive 1. I can apply L inverse, but just for sake of consistency I refrain from doing it. So I'll just rewrite all the terms one more time. So this is what I've got. Of course, the negative sign has to be placed outside the parenthesis. So this is going to be 2 times L inverse of S over S squared positive 1. That is going to give us cos t. This is going to give us 1, and this is going to give us e raised to the power of negative t. If I were to bring the negative sign inside, then this is going to be negative 2 times cos t, positive 1, positive e raised to the power of negative t. But this is nothing but t times f of t, right? So if I want to just have f of t, then I bring the t down. So this is going to be 1 over t times, I start with writing 1 first, and then I will write e raised to the power of negative t next, followed by negative 2 times cos t. So this is the solution to the question, students. Be using partial fractions. So we have been given this question, L inverse of 3s positive 2 divided by s negative 1 times s negative 2. So what I have done here is I have taken this quantity separately and I have rewritten as 3s positive 2 divided by s negative 1 times s negative 2 to be equal to a over s negative 1 positive b over s negative 2. Then what I would do is I would cross multiply, and that would give me a times of s negative 2 positive b times of s negative 1. Now the idea is to get rid of the quantities one by one. So if you want to get rid of this quantity a, I would just say put s to be equal to 2 in 1. So I take this as 1. So if I were to take s is equal to 2, this will vanish, leaving me with b times of 2 negative 1. On the left side, it's going to be 3 times of 2 positive 2. 3 times 2, 6, 6, 7, 8, and this is going to be b. So this means I got the value of b as 8. Now next I can get rid of b now. So for that I would say put s is equal to 1. When I do that, this is going to be b will vanish. So I will have a of 1 negative 2. On the left hand side it's going to be 3 times of 1 positive 2. So it's going to be 3 positive 2 is equal to negative a. So 5 is equal to negative a. So therefore I get the value of a to be as negative 5. So I've got a value for a, I got a value for b. All that I will do is, hence we can now rewrite 3s positive 2 divided by s negative 1 times s negative 2 to be as negative 5 over s negative 1 positive 8 over s negative 2. So wherever I find this quantity, I can replace this with this quantity. So that's all about. So let's do that. So hence I can rewrite this. If I were to take this as 1 prime, so therefore 1 prime becomes L inverse of, in place of this entire component I'm going to use negative 5 over s negative 1 positive 8 over s negative 2. By linearity I can rewrite this as negative times of L inverse of 5 over s negative 1 positive L inverse of 8 over s negative 2. So this is going to be, I can take the 5 out and I write this as L inverse of 1 over s negative 1. I can take the 8 out and write this as L inverse of 1 over s negative 2. So this is going to be negative 5 times, shift is s negative 1, so we are going to get e raised to the power of t, positive 8 times, this is going to be e raised to the power of 2t. So this is my solution to this question. Students, we are given this question to find the Laplace inverse of 6 positive s negative 1 times s squared negative 5s positive 11, that is being divided by s times of s negative 1 times of s negative 2 times of s positive 1. So what I would do is, first I would have to use partial fractions. As you are aware that all of these questions would be using partial fractions to solve. So having mentioned that, let me just consider the numerator 6 positive s negative 1 times s squared negative 5 times s positive 11 divided by s of s negative 1 times s negative 2 times s positive 1. I can rewrite this as a over s positive b over s negative 1 positive c over s negative 2 positive d over s positive 1. Now if I were to cross multiply, I would get 6 positive s negative 1 times s squared negative 5 times s positive 11 to be equal to a times of, now the s gets cancelled, giving me s negative 1 times s negative 2 times s positive 1, followed by my b, which is going to be s negative 1 gets cancelled, so I will have a s, I'll have a s followed by s negative 2 and s positive 1, and then for c I will have a s and then s negative 1 and then s positive 1, followed by, for my d, I will have a s negative 1 and s negative 2. So now we will have to find the values for a, b, c and d. So how are we going to do that? Foremost, if I were to take s is equal to 0, this is the easiest one. Let s be equal to 0. When I take s is equal to 0, this vanishes, this vanishes, this vanishes, but the value for a will stay put. So 0 minus 1 times 0 minus 2 times 0 positive 1, which is negative times negative will be positive, so that's going to be the 2 there, and I have a 1 here. 2 times 1, that's going to be 2a. S is equal to 0, so this is going to be 6 positive, that's negative 1 there. This will vanish, you get a 11 there. So in fact you get 6 negative 11, that was going to be 5, right? So this is going to give me negative 5, therefore the value of a is going to be negative 5 over 2. This is my first value. Now I've got the value for a. Now let's move on. Next I would like to take s to be equal to 1. So if I want to take s is equal to 1, this will vanish, this will vanish, this will vanish, but b will stay on. So let me use the space here to obtain the value for b. So it's going to be b of 1, 1 negative 2 times 1 positive 1. I get a negative 1 here, this is 2 negative 2, so it's going to be negative 2 times b. On the left side I need to substitute s is equal to 1. If I substitute s is equal to 1, this goes off clearly, right? S is equal to 1, this entire thing will become 0. I just get a 6. So 2 divides 6 3 times, so therefore the value of b is negative 3. Okay, I got a value for b, and now it's time for me to obtain the value for c. Now to get the value for c, I would, let me just take s to be equal to positive 2 first. Let me get rid of d. So I'm using this space here. So let s be equal to 2. If I were to take s is equal to 2, this will vanish, this will vanish, this will vanish, but this would not vanish. So it's going to be c of 2 times 2 negative 1 will give me 1, 2 positive 1 will give me 3. So on the left side I got s is equal to 2, so 2 minus 1 will give me 1. This is s squared, so it's going to be 4 negative 10 positive 11, right? So 4 added with 11 will give me 15. 15 minus 10 will give me 5, so this is going to give me 5 plus 6, that's going to give me 11. So let me just check one more time. S is equal to 2 squared is 4, 10 and 11 added with 4, 15, and then I get a 5. That's right, 5 added with 6 will give me 11. That's fine. 3 times 2 is 6, so therefore my value of C is 11 over 6. So fair enough. So I was able to get the value for A, B, C. Now we need to get the value for D. Now for D, I can substitute, say S is equal to any value. It doesn't matter, because we would ultimately arrive with A, B, C, and subsequently we can use these. So let us just check out the shortest way by which we can obtain the value for D. Okay, the best thing to do is substitute S is equal to negative 1. If I were to take S is equal to negative 1, then S is equal to negative 1, this will vanish, this will vanish, this will vanish, and all that we have is only D. So let me just evaluate the value for D here. So negative 1, that's going to be D of negative 1. Negative 1 will give me negative 2. Negative 1, negative 2 will give me negative 3. That's fine. So negative positive, 3 times 2 or 2 times 3 will give me 6. With 6 times negative 1 will give me negative 6 times D. On the left hand side it's negative 1. So if I were to place negative 1, this would be negative 2. Negative 1 squared will be 1. Negative 1, that's going to be positive 5, positive 11. 5 added with 1 will give me 6. 6 added with 11 gives me 17 times 2, negative 34. So I have negative 34 added with a positive 6, that's going to give me 28 with a negative sign. So I get a negative 28. So positive, so 28 divided by 6. So therefore my D is going to be 28 divided by 6. So 2 divides here 14, 2 divides here 3 times. So 14 over 3. So this is going to be 14 over 3. This is my D value. So let me write the values down. I've got A to be as negative 5 over 2. This is my value for A. My value for B is negative 3. My value for C is 11 over 6. And my value for D is 14 over 3. Now the question comes, we will have to substitute all of these values and then obtain the Laplace. So let's do this. So wherever I find this, I would have to replace this. So in fact what I can do is, probably I can just use this space over here and finish it off, because probably I can retain my continuity. So this entire thing will be equal to L inverse of negative 5 over 2 divided by S, followed by positive of negative 3 over S negative 1, followed by 11 over 6 divided by S negative 2, followed by 14 over 3 divided by S positive 1. So by linear property we can use linearity in Laplace inverse. So that would give me negative 5 over 2 times L inverse of 1 over S, L inverse of 1 over S, followed by negative 3 L inverse of 1 over S negative 1, followed by 11 over 6 L inverse of 1 over S negative 2, followed by 14 over 3 L inverse of 1 over S positive 1. So this is what I have got. Now if I can obtain the corresponding values, then the question is finished. So this quantity L inverse of 1 over S is going to be 1, so I can safely write that to be as negative 5 over 2, followed by negative 3, 1 over S minus 1, that's going to be e raised to the power of positive t, followed by 11 over 6, 1 over S negative 2, that's going to be e raised to the power of 2t, and followed by 14 over 3, and 1 over S positive 1 is going to be e raised to the power of negative t. So this is the solution for this question, students. I hope you had followed this. So we will move on to the next one. Students, we are given this question. We are expected to find the Laplace inverse of 8 negative of S positive 2 times 4S positive 10 divided by S positive 1 times S positive 2 raised to the power of 2. Now this can be done by partial fractions, but the technique is a bit different. So I'm going to show you the technique. So first what we will do is we will consider this quantity. That's what I'm going to do. Consider 8 negative of S positive 2 times 4 times S positive 10 divided by S positive 1 times S positive 2 raised to the power of 2. Now I'm going to rewrite this as A over S positive 1 positive B over, now you got this S positive 2 raised to the power of 2, right? So we will split this as S positive 2 for the first quantity, and then for the second quantity I'm going to split this, in fact I'm going to write it as it is, S positive 2 raised to the power of 2. So this is the pattern in which you will have to use the partial fractions whenever you encounter a pattern of this form. So it's all pattern matching. Now if I were to cross multiply this, I would get 8 negative of S positive 2 times 4 times S positive 10 is equal to A times of S positive 1 gets cancelled, giving me S positive 2 raised to the power of 2, followed by B times of S positive 2, I will have 1 S positive 1, in fact I will just have a S positive 1 followed by an S positive 2, and then that will be followed by C times S positive 2 whole square will be absorbed, giving me C times of S positive 1. So this is what I've got. Now I have to find the values of A, B and C. So the best way is just take the value for S to be as, say, negative 2. If I were to take S to be as negative 2, what happens? This one gets vanished, this one gets vanished, and I would be left with this. So it's going to be C of negative 2 positive 1. On the left side, negative 2, everything goes off, so I get 8 here. So this is going to be negative 2 positive 1 will give me negative C followed by 8, therefore the value of C is negative 8. So successfully I got one value of the quantities that listed here. Next what I wish to do is I would like to take S to be equal to negative 1. So when I take S to be negative 1, this vanishes, but this stays. So this is going to be A of negative 1 positive 2 raised to the power of 2. So that will give me a positive value here. So it's just going to be A. And on the left hand side I have taken S to be as negative 1. Apparently I will have to substitute the values. So it's going to be 8 negative of negative 1 positive 2 of 4 times of negative 1 positive 10. So this is what I've got. So this is going to be 8 negative of negative 1 positive 2 will be positive 1, and 4 times of negative 1 will be negative 4,
and positive 10 is equal to a. So this is going to give me 6, and 8 negative 6 is equal to a, therefore the value of a is going to be 2. So this is what I've got, a is equal to 2, and I've got a value for c. Now next I will have to obtain the value for b. So let's do that. Now to get the value for b, you can just simply substitute s to be equal to 0. Let s to be equal to 0. So that would give you 0 here. So let me write that down. 0 positive 2 squared positive b times of 1 positive of 2 positive c of 1. On the left hand side, this is going to vanish, 0. So you get a 10 and you get a 2 there. 2 times 10, 20. So this goes up, this goes up. So you have 8 negative of 20. That's going to give you negative 12 is equal to 4 times a plus 2 times b plus c. My c is negative 8. I need to find my b. My a is 2. So this and this gets cancelled. So I get 2 times b is equal to negative 12. Therefore the value of b is negative 6. So what I need to do, I need to take these values, all of these values, and substitute here instead of this. So this can be rewritten as L inverse of my a is 2 over s negative 1, s positive 1. My b is negative 6 divided by s positive 2, and my c is negative 8. So 8 over s positive 2 raised to the power of 2. So all I need to do is to obtain the Laplace transform of this. So that is going to be L inverse of, I can take the 2 out, it's going to be 1 over s positive 1 negative 6 times L inverse of 1 over s positive 2 negative 8 times L inverse of 1 over s positive 2 raised to the power of 2. So this is what we have got. Now this is going to be L inverse of 1 over s positive 1, that's going to be e raised to the power of negative t, negative 6 times this is going to be e raised to the power of negative 2 t, and this is going to be negative 8 times e raised to the power of this. There is a shift of s positive 2 and you have a degree 2 there, so this is going to be e raised to the power of negative 2 times t, and you have to obtain the L inverse of 1 over s squared. So this is going to be 2 times e raised to the power of negative t, negative 6 times e raised to the power of negative 2t, followed by 8 times e raised to the power of negative 2t, and this is s squared. So that means t raised to the power of 1 divided by 2 minus 1, that's going to be 1 factorial, right? So if I were to rewrite this by taking e raised to the, can I take anything in common? Probably I cannot take anything in common for all of these, so I just retain it and write it as 2 times e raised to the power of negative t, and 6 times e raised to the power of negative 2t, and 8 times t times, and there's a t there, right? So 8 multiplied with t e raised to the power of negative 2 times t. So this is what I get. So this is the final solution for this question. Students, we will move on to the next one. Students, we are given this question: Laplace inverse of s squared negative 5s positive 7 divided by s positive 2 raised to the power of 3. Now this is a different way of partial fractions. In other words, we need to adopt a different type to represent this. So that's exactly what I'm going to show to you. So I'll start off by saying consider s squared negative 5 times s positive 7 divided by s positive 2 raised to the power of 3, and I'm going to represent this as a over s positive 2 followed by b over s positive 2 raised to the power of 2 followed by c over s positive 2 raised to the power of 3. So this is the way you have to fragment this component which you see in the denominator.
Now if I were to cross multiply, I can rewrite this as s squared negative 5 times s positive 7 is equal to a times of s positive 2 raised to the power of 2 positive b times of s positive 2 positive c. Now if I were to take s is equal to 0, let me just do that. To begin with, what I'll do is I'll take let s to be equal to negative 2. Now this will vanish, right? This is going to vanish, this is going to vanish, and I'm left with c. And then s is equal to negative 2, so this is going to be negative 2 raised to the power of 2, negative 5 times of negative 2 positive 7. Now I can rewrite this as 4 negative positive 5 times 2 is 10 positive 7 is equal to c. 4 added with 10 will give me 14. 14 added with 7 will give me 21. So therefore my c is 21. So that's the first value we have got. Now if I were to take the value for s to be as say 0, then if I were to do that, this is going to be 0 2 squared, right? So it's going to be 4 times a, and 0 positive 2 times b positive c is equal to, this is going to vanish, this is going to vanish, and I get a equation 7, but my c is 21, so I can replace that 4a positive 2b positive 21, and you got a 7 there. If I were to push this over here, it's going to be 7 negative 21 is equal to 4a positive 2b. So I've got one system there. So this, when we subtract this is going to give me negative 14 is equal to 4a positive 2b. Now I divide by 2 both sides, and that would give me 2a positive b is equal to negative 7. So let me have this as one system. Right. Now next what I can do is I can just simply some random value. So let me just take I've taken negative 2, I've taken 0. Let me take s to be equal to some 1. If I were to substitute that value there, I would get a of 1 positive 2 raised to the power of 2 positive b of 1 positive 2 positive c. This is 1 squared negative 5 positive 7. This is going to be negative 4 positive 7 is equal to 1 positive 2 3 squared is 9 times a positive 3 times b positive c is 21. So substitute the value 21. Now this is going to give me 3, and I can bring this 21 to this side, so it's going to be negative 21. So that would in turn would give me negative 18, and on the right hand side I have a 9a positive 3b. If I were to divide by 3 both sides, then I'm using the space. This is going to give me negative 6 is equal to 3 times a positive b. So I have got system 2, so I will use the system 2 here. So I get a 3a positive b and then negative 6. If I were to change the signs here, negative, my b will get cancelled. This will give me negative a, and I have a negative 7 and a negative 6, and in fact this is negative, so this should be positive. Yeah, so changing the signs, right? So this is going to give me negative 1, so therefore the value of a is 1. So if a is 1, I can just simply substitute the value of a into 1 or something. So you put a is equal to 1 in 1, we get, so what do we get? Negative 7 positive 2 times of 1, this is equal to, right, negative 7 equal to 2 times of 1 positive b. This
This is 2 positive b is equal to negative 7. You push this here, and that would be negative 7 negative 2 is equal to b. Therefore b is equal to negative 9. So you have the following values. You get a is equal to 1, b is negative 9, and c is equal to 21. So you got to use all of these values into this system and obtain the Laplace inverse. So let's just do that. So therefore L inverse of this quantity, I'm going to rewrite this quantity using this. So my a is 1. We have, just say we have L inverse of 1 over s positive 2. My b is negative 9 divided by s positive 2 raised to the power of 2. My c is 21 divided by s positive 2 raised to the power of 3. By linearity, I can rewrite this as L inverse of 1 over s positive 2 negative L inverse, I can write 9 out, 1 over s positive 2 raised to the power of 2 positive 21 L inverse of 1 over s positive 2 raised to the power of 3. Now this is going to be e raised to the power of negative 2 times t, negative 9 times e raised to the power of negative 2 times t, L inverse of 1 over s squared, positive 21 e raised to the power of negative 2 times t, L inverse of 1 over s to the power of 3. This is rewritten as e raised to the power of negative 2t, negative 9 times e raised to the power of negative 2t. This is going to be t divided by 1 factorial plus 21 e raised to the power of negative 2t. This is going to be t squared divided by 2 factorial. So if I were to take e raised to the power of negative 2t out, I would get 1 negative 9 times t divided by 1 factorial. You don't have to specify that, it's understood. Positive 21 times t squared divided by 2. 2 factorial is 2. So this is the solution for this question, students. Students, we are given this question. We are expected to find the Laplace inverse of 3s positive 1 divided by s negative 1 times s squared positive 1. Now we would be using a partial fractions variation in solving this question. So this is the another important variation in partial fractions that we need to pay due attention to. So foremost, what I would do is I would just say consider 3s positive 1 divided by s negative 1 times s squared positive 1. Now this is rewritten, in fact this is represented as a over s negative 1 positive b times s positive c divided by s squared positive 1. Upon cross multiplying, I would get 3s positive 1 on the left hand side. On the right hand side, I would be getting a of s squared positive 1 positive b s positive c of s negative 1. So this is what I would get. Now first what I will do is I will let s be equal to 1. When I do that, this vanishes, so this would give me 1 squared, that's 1 positive 1 is going to be 2 times a, s is equal to 1, so 3 positive 1 will be giving me 4, therefore I get 4 over 2, and this would mean a is equal to 2. So I got the first value of a. Next what I would do is I would like to take s to be equal to 0. Now when I do that, this will vanish, b will vanish, my c will stand here, but s is 0, so the value with c, the coefficient of c is going to be negative. Now followed by s is 0, I will have a there, and s is 0, I will have a 1. So this is clearly working out in our favor because I can substitute the value of a, and from here I can obtain the value of c, and this is negative 1 negative c, therefore the value of c is positive 1. So that's neat and tidy. So I've got the value of a and value of c. Now all I need to do is pick up a random value and then substitute over in this system. So So what I will do, I will pick up a value, say s is equal to minus 1. If you were to pick s is equal to, it doesn't matter, minus 1, because I was thinking of getting rid of any possible terms here, but that doesn't seem to be working out. So let's take s is equal to, say, minus 1. So I will get negative 1 squared. That's going to give me 1 and 1, so 2 times a over there, followed by negative 1. So I will have a negative b, positive c, negative 1. That's going to give me negative 2 there. So if I were to rewrite this, is going to be 2 times a, negative 2 times negative b will give me positive 2 times b, and negative 2 times c. On the left side, negative 1, so negative 3, positive 1, this is going to give me negative 2. I got a value for a, I can substitute it. My value for a is 2, so it's going to be 4 there, followed by 2 times b. My value for c is 1, it's going to be 2 there with a negative sign, and I get a negative 2 here. So 4 added with negative 2 will give me positive 2, so it's going to be 2 times 2b, followed by a negative 2 there. So negative 2, I move the 2 this side, it's going to be negative 2, followed by equal to sign and a 2b. So negative 2 added with negative 2 will give me negative 4. I already get a 2b, therefore my value of b is negative 4 divided by 2, which is equal to negative 2. So I get a value for b as negative 2, I get a value for a, I get a value for c. All I need to just do is substitute them over there and obtain the Laplace inverse. So this is equal to L inverse of my a value is 2, so it's going to be 2 over s negative 1, followed by my value of b is negative 2, negative 2 times s, followed my c is 1 divided by s squared positive 1. I can rewrite this as L inverse of 2 over s negative 1, followed by, I have a negative sign, I can take the negative sign, I can take the 2 out and write this as L inverse of s over s squared positive 1, positive L inverse of 1 over s squared positive 1. So this is what I have got. So in fact I can take the 2 out. So if I were to take the 2 out and operate on using L inverse, this would be e raised to the power of t, because of the shift being s negative 1, followed by negative 2 times, this is s over s squared plus 1, that would give me cos t, and this is 1 over s squared positive 1, and that is going to give me sin t with a positive sign. So this is the solution to the question, students. Students were given this question: find the Laplace inverse of 1 negative s of 5 positive 3s divided by s of s positive 1 raised to the power of 2 positive 1. Now we will be employing partial fractions, and this is the variation that I have just spoken about in the previous question. So let us apply the same variation for this. So what I would do is I will first consider 1 negative s of 5 positive 3 times of s divided by s of s positive 1 raised to the power of 2 positive 1. Now I'm going to rewrite this as a over with this s followed by bs positive c divided by s positive 1 raised to the power of 2 positive 1. So this is the way you have to follow. Now cross multiplying, I get 1 negative s times of 5 positive 3 times s is equal to a of s positive 1 raised to the power of 2 positive 1 positive b s positive c times of s. Now I need to get rid of these quantities one by one so that I am able to get the values. So first thing first, what I would do is I would just let s be equal to 0. If I were to do that, this inequality will get vanished. So this is going to be 0, positive 1. That's going to give me 1, and 1 squared is 1, and I got a 1 over here, so it's going to be 2 times a. This is 0 and this is 0. In fact, this would clearly give us a value of a being equal to 1 over 2. So that is so simple. Now, having obtained the value of a, now let me just take the value of s to be as negative 1. If you were to take the value of a to be as negative 1, this will vanish, but a will still remain, and followed by s is negative 1. So this is going to be negative b, positive c of negative 1, and I have a negative 1 there, so it's going to be 1 negative of negative 1 times 5 negative 3, because s is equal to negative 1. So this will give me a 2, and it's going to be positive, so it's going to be 1 positive 2 is equal to my a is 1 over 2, and this will give me a positive b and a negative c, and 2 positive 1 or 1 positive 2 is going to be 3. I can move this 1 over 2 to the left. That's going to be negative sign there, so you get a b negative c equal to 6 negative 1 over 2, which is going to be 5 over 2, which is going to be equal to b negative c. So I got a equation there. Now I have taken the value of s to be as 0, s to be as negative 1. Now let me take the value of s to be as 1, so that I can get a system and then I can solve it. So if I take s to be as 1 on the left side, I get a 1, negative 1, 5 positive 3, that's fine. So this is going to be s is 1, 1 positive 1, 2, 2 squared is 4, 4 positive 1 is 5, and s is 1, so b positive c, and that's it. So a is already equal to 1 over 2. I substitute the value here, so it's going to be 5 over 2, positive b, positive c, and this is going to be 5 positive 3, 8, so 1 negative 8, it's going to be negative 7 is equal to 5 over 2, positive b over c. I will use the space here. I will move this 5 over 2 to the left, so it's going to be negative 7, negative 5 over 2 is equal to b positive c. This is going to give me 14 negative 5 over 2 is equal to b positive c. So therefore b positive c is equal to negative 19 over 2. So I take this as 2, I take this as 3. So I have b negative c is equal to 5 over 2. B positive c is equal to negative 19 over 2. I add this, I get 2 times b is equal to 5 over 2, negative 19 over 2. I take the LCM as 2. This is going to give me 5 negative 90, which is negative 14 over 2 is negative 7. So 2b is equal to negative 7, therefore b is equal to negative 7 over 2. So I get the value for b. I can substitute it in this or in this. So let me substitute it in 3. So negative 7 over 2, positive c is negative 19 over 2. So I move this on this side. So c is negative 19 over 2, positive 7 over 2. So I take the LCM. So negative 19 positive 7, that's going to give me negative 12. So negative 12 over 2 is going to give me negative 6. So my c is negative 6. So I've got a c, I've got a b, and I've got a a. So we need to substitute these values now. So now instead of this I would have this. So this is going to be L inverse of a, my a is 1 over 2 divided by s, my b is negative 7 over 2
So let's substitute it there. So negative 7 over 2 times s divided by s positive 1 raised to the power 2 positive 1, and my c is negative 6. We got negative 6 for c, so substitute that. So this is what we have got. So we can rewrite this as L inverse of 1 over 2. I can take it out, so it's Laplace inverse of 1 over s. 7 over 2 I can take it out. This is Laplace inverse of s divided by s positive 1 raised to the power of 2 positive 1. So I'm going to split it like this and write it. And negative 6 I can take it out, and this is going to be L inverse of 1 over s positive 1 raised to the power 2 positive 1. So we need to do some calculations here. So clearly you can see that there is a shift of s positive 1 taking place in the denominator, but there isn't any here. So to achieve that, I'm going to add 1 and subtract 1. So I will have to rewrite this as, I'm not going to take the Laplace inverse as such now. I will just set up these terms. So this is going to be 1 over 2 times L inverse of 1 over s negative 7 over 2, and I'm going to rewrite this as L inverse of s positive 1 divided by s positive 1 raised to the power of 2 positive 1. This is one component, followed by L inverse of 1 over s positive 1 raised to the power of 2 positive 1. This is the another component, followed by negative 6 times L inverse of 1 over s positive 1 raised to the power of 2 positive 1. So this is, I'm just writing it as it is. Now I'm applying Laplace inverse. So this is going to be 1 over 2 times L inverse of 1 over s, that is going to be 1, followed by negative 7 over 2. The shift is s positive 1 as I mentioned to you. So if I were to apply the shift, this is going to be e raised to the power of negative t, L inverse of s divided by s squared positive 1. And of course I will have to be careful because the 7 over 2 is coming in, followed by, if I were to apply the shift, this is going to be e raised to the power of negative t and Laplace inverse of 1 over s squared positive 1. So this is what I have got for this term, followed by negative 6 times the shift. I'm applying the shift, so e raised to the power of negative t followed by Laplace inverse of 1 over s squared positive 1. So this is what I've got. Now this is equal to 1 over 2 negative 7 over 2 e raised to the power of negative t. This is going to be my cos t, negative e raised to the power of negative t. This is going to be my sin t, that's fine, followed by negative 6 times e raised to the power of negative t. This is going to be my sin t. Now let me remove the parenthesis. So this is going to be 1 over 2 negative 7 over 2 times e raised to the power of negative t times cos t, positive 7 over 2 times e raised to the power of negative t times sin t, negative 6 times e raised to the power of negative t times sin t. Okay, so I can very well take e raised to the power of t out. Now I can in fact simplify these two components, right? So this is going to be, I can take e raised to the power of negative t out, I can take a sin t out. Now if I were to do that, I get 7 over 2 negative 6. That is going to be, I take the LCM as 2, 7 negative 2 times 6 is 12, which is going to give me negative 5 over 2. Of course you get e raised to the power of negative t sin t. So I would write this first, negative 7 over 2 times e raised to the power of negative t cos t, and this is going to give me negative 5 over 2 times e raised to the power of negative t times sin t. Now I can
take a common quantity of e raised to the power of negative t out, in fact I can take 2 out, so that would mean I will have a cos t with a 7 there, right? And since I've taken a negative sign out, this will become positive 5 times sin t. So this is what we've got as the final solution. You can check it out and see, students. We will do one more question on Laplace inverse transforms using partial fractions, students. So we've been given this to obtain the Laplace inverse of this component 8 positive 3 times s divided by s squared positive 1 times s squared positive 4. So the degree being 4 here. So what I will do, I will start off by consider 8 positive 3 times s divided by s squared positive 1 times s squared positive 4. I'm going to rewrite this as as, in fact I will rewrite it as a positive bs. A positive bs divided by s squared positive 1, and then followed by c positive ds divided by s squared positive 1. I'm just writing it for the sake of convenience. You can always interchange the presence of s depending on what you want, but I prefer it in this fashion, so I'm using it. Now cross multiplying, I would get 8 positive 3 times s is equal to a positive bs. S squared positive 1 will get absorbed, giving me s squared positive 4, followed by c positive ds times s squared positive 4 will get absorbed, giving me s squared positive 1. Now the question is to eliminate and to find the value of a, b, c. So what I would do is I would start off by taking s is equal to 0. That's a standard substitution we can use. So if I were to take s is equal to 0, my b will go, leaving me with 4 times a, followed by my d will go, leaving me with c, and on the left side I get 8. So that is one particular system we have got. Now the next thing is, if I were to take s squared is equal to, but the problem is we wouldn't be able to take s squared is equal to negative 1, so that would give us a complex quantity. Now what I would do is I would just take the values for s in this fashion. Then I need to solve it. So I will start with s is equal to 1. If I were to take s is equal to 1, I would have a positive b times s is equal to 1, so it's going to be 1 positive 4, it's going to be 5 there, followed by c positive d, and 1 positive 1 is going to be 2. S is equal to 1, so that would mean 8 positive 3, that would give me 11. So if I were to rewrite this, I get 5 times a positive 5 times b positive 2 times c positive 2 times d. This is one system is equal to 11. Now I will have to take one more value for s, so let me name it as system 2 or equation 2. This is going to be 1. Let me take s to be equal to negative 1. If I were to take s is equal to negative 1, I substitute here, this is going to be a negative b, and s is equal to negative 1 positive, so 1 positive 4 is going to be 5 positive. C, s is equal to negative 1, c negative d, s is equal to negative 1, that's going to be 1 positive 1 is going to be 2, and s is equal to negative 1, that's going to be 8 negative 3, which is 5. This is going to give me 5 times a negative 5 times b positive 2 times c negative 2 times d. This is what I get. So I get system 3. Now I would have to get one more equation, because as of now we can eliminate one variable from here, so that leaves us with 3. So we need to simultaneously have subsequent systems. So you can clearly see that if I were to use this substitution technique, I would be needing more equations for solving, but there is an easier way. So what I would do is I would expand these things, and that would give me a times s squared positive 4 times a, and bs cubed positive 4 times b times s, and then followed by c times s squared followed by c positive ds cubed positive ds. On the left hand side I got 8 positive 3 times s. Now what I will do is I will equate the coefficient of s cubed. So I'm going to write that, equating the coefficient of s cubed. So what do I get here? I get a s cubed here, that's going to be b. I get a s cubed here, that's going to be d, and the coefficient of s cubed is 0. So this is one system. So next I would be equating the coefficients of s squared, and that would get me s squared. I get a here, and then I get a c there. Is there anything else I have? No. A, c, and that's going to be 0. Now next, equating the coefficient of s. Coefficient of s, I get a 4b there, and then coefficient of s, I get a d there, and coefficient of s, I get a 3 there. So this is my system 3. Next, constant term, equating the constant term. So what is a constant term? I got a 4a here, 4a, then I get a c there. Anything else? On the left side I get a 8 there. So this is going to be 4. So I've got 4 systems easily. So what I would do is I would try to solve from 2. I can get a is equal to negative c. I substitute the value here, a is equal to negative c. Okay, put a is equal to negative c in 4. So in place of a I substitute negative c. So this is going to be 4 times of negative c positive c is equal to 8. So negative 4c positive c, which is negative 3c, and I get c is equal to 8 over 3 with a negative sign. So c is equal to negative 8 over 3, but my a is negative c, so therefore from here a is positive 8 over 3. So I got that. I got the value for a, I got the value for c. Now let me see what I can do with b and d. So over here, b positive d is equal to c is equal to 0, therefore b is equal to negative d. I get b is equal to negative d, I substitute it here. So what do I get when I do that? So I get 3 is equal to 4 times b is equal to negative d. So I substitute that and I get a d there, and over here negative 4d positive d, this is equal to negative 3d is equal to 3. Therefore my d is equal to negative 1, my d is equal to negative 1, my b is equal to positive 1, right? Because b is equal to negative d. So I've got a, b, c, d, all the values I've got. All I need to do is to substitute them into the system. So this is equal to L inverse of my a is 8 over 3, and my b is positive 1, divided by s squared positive 1. My c is negative 8 over 3, my d is -1, that's going to be -s divided by s squared positive 4. So now I need to simplify this. I can rewrite this as 8 over 3 L inverse of 1 over s squared positive 1 positive L inverse of s over s squared positive 1 negative 8 over 3 L inverse of 1 over s squared positive 4 negative L inverse of s over s squared positive 4. So I got that. Now this is going to be 8 over 3 Laplace inverse of 1 over s squared will give me sine t. This is going to give me cos t. This is going to give me, it's 2 squared there, right? So sine 2t times 1 over 2, that's what it will produce. Negative, this is going to be 2 squared, so this is going to be cos 2t. So if I were to rewrite this, this is going to be 8 over 3 sine t followed by 2 divides here 4 times, so negative 4 over 3 sine 2t followed by cos t and cos 2t. You can either write it as cos t negative cos 2t as the first quantity followed by 8 over 3 4 over 3. So in fact you can take 4 over 3 out, and that would give you 2 times sine t negative sine 2t. So this is your solution, students. Thank you so much.
Welcome students, we have been given this question to find the Laplace inverse of s over s squared positive 1 raised to the power of 2. Of course, I have already explained to you that questions of this nature can also be solved using partial fractions, but the only thing is that it is very cumbersome. So for that we would have in other words, we would have to resort to a easier technique, what is called as convolution. Now we have been embarked on this particular topic of solving questions related to Laplace transforms, specifically inverse Laplace transforms, using convolution concept. Now just to have a recap, now if you have two functions, say f star g of t, and you have two functions and you are convoluting these two functions, then you got this convolution of these two functions to be represented as integral 0 to t, and this is going to be f of t minus u times g of u times du. Now since convolution is commutative, you can also have the reverse of this, which I've already explained to you. So for this question I would be using this convolution to obtain the solution. Now to start off, what we have to do is we will have to split this given Laplace inverse. So I'm going to rewrite this as L inverse of 1 over s squared positive 1 times s over s squared positive 1. Now s squared positive 1 times s squared positive 1 will give us s squared positive 1 raised to the power of 2. 1 times s will give us s. So it's just writing it as a product, so there isn't any convolution appearing here. But if I rewrite this as L inverse of 1 over s squared positive 1 asterisk L inverse of s over s squared positive 1, now comes the convolution. You have to understand that convolution is not product, we call it as asterisk, that's it. Now L inverse of 1 over s squared positive 1, or in other words L inverse of 1 over 1 positive s squared, this is going to be my sine t. and that is convoluted with s over s squared positive 1. You are taking Laplace inverse. This is going to be my cos t. So you have two functions. So you got this as f of t star g of t, which is nothing but f star g of t. So this is what we are looking for. Now we have to use the technique of convolution onto this particular function. So that's exactly what we are going to do now. Now using this formula, I can rewrite this as integral 0 to t. Now my f of t is sin t. So from here, f of t negative u can be rewritten as sine of t negative u. So this is going to be my sine of t negative u times g of t. My g of t is cos of t. So my g of u is going to be my cos u. So we can write that cos u times du. Now we have obtained this. From here we can use compound angle formula. So what I'm going to do is I'm going to use this formula. So we know that half times, in fact let me just use this in this fashion. We know that sine of a times cos of b is equal to half times sine of a minus b. This is a very important formula. Positive sine of a positive b. So if you were to expand this, you will get back this. So I can just show you that. Why am I writing this? So this is equal to half of, now sine of a minus b is going to be sine a cos b minus cos a sine b. Positive sine of a plus positive b is going to be sine a cos b positive cos a sine b. Right. Now sine a cos b, these two can be added. Negative cos a sine b, positive cos a sine b, these two can be cancelled. So what do you get? You get 2 times sine a cos b, and that is product multiplied with 1 over 2. So 2 gets cancelled, giving you sine a cos b. So that is why this is a very important formula. So what exactly are we doing? We're connecting a product with a sum. Now why is it important? Specifically in integration, whenever you have trigonometric functions or exponential functions, one of the easiest way to solve them is to convert the product form into sum form. So that is simple as that. Now we have got sine of t minus u times cos of u. So let me rewrite that. Now sine of t minus u times cos of u. Now my a is t minus u, this is my a, my b is cos u. So I'm going to rewrite this as half of sine of my a t minus u and my b is cos u, I mean u, followed by positive sine of my a is t minus u and my b is u. So let me have it like this, my b is u. So this is going to be rewritten as 1 over 2 times sine of t, negative u will give you negative 2u, positive, negative u, positive u, this can be cancelled, giving you sine of t. So wherever I see sine of t minus u times cos of u, I'm going to replace this. So let's go over here. So if I were to take this as 2, I'm going to say therefore 2 can now be rewritten as integral 0 to t. This is 1 over 2 times sine of t negative 2u positive sine t. Now this has to be multiplied with my du. Now I'm going to rewrite this as, now you got a half there, so I can take the half out and rewrite this as integral 0 to t sine of t negative 2 times u times du positive 1 over 2 times integral 0 to t sine of t times du. So this is what we have got. In fact, okay, that's okay. I place a parenthesis. That's fine. So now we will have to integrate this and then add it up with the integrated value of this. So to integrate this, what I wish to do is I would like to consider integral 0 to t sine of t negative 2u times du. Now use the function here. So I'm going to say let t negative 2u be equal to some p. So I differentiate this left hand side, so I get negative 2 times du is equal to dp. I want only du, so du is equal to dp. I bring the 2 down. In fact, I'm bringing negative 2 down, so it's going to be negative 1 over 2. So this is the substitution that I have to use. So hence what happens, this is equal to integral. So I'm just drawing a line here. Probably I will take this as 4 or 3. So hence this thing integral, I'm not going to touch the integral limits, so let it be like that. In fact, I'm not going to place anything there. So this is going to be sine of t negative 2u, that's going to be p, and du is going to be dp divided by, in fact multiplied with 1 over 2 with a negative sign. So place that 1 over 2, place the negative sign. Now if you were to integrate sine p, this is going to be negative cos p. Of course there is a 1 over 2 there, but there is a negative sign there, so place that. Now this can be rewritten as 1 over 2 cos p. But what is p? P is nothing but t negative 2u. Now the limits, what are the limits? The limits are 0 to t, because I've not brought them back to the original t minus 2u. So now I can substitute the limits. So if I were to substitute the upper limit, so this is going to be cos of t negative 2 times t negative cos of t negative, u is 0, so you place it there. So this is going to give you 1 over 2 times cos of t negative 2t, that's going to be negative t, and this is going to be negative cos of t. So this is what you have got. Now you can rewrite this is going to be 1 over 2. Now cos is an even function, so cos of negative t is going to be cos t followed by negative cos t. Now clearly you can see cos t negative cos t, they get cancelled, so giving you 0. So the value of the integral is 0. So clearly this vanishes. So I'm not going to do anything now. I need to just first get this quantity out of my way. So now I'm going to say consider integral 0 to t sine of t times du. Now this is a constant, so I can rewrite this as sine of t integral 0 to t times du. Now this is equal to sine of t, integral of du will give me u, the limits are 0 to t, so this is equal to sine of t, substitute the upper limit minus the lower limit. So this one is going to be t times sine of t. So this is what you have got for this. Now I need to take all these values and substitute it in 3. Okay, so hence my 3, I can rewrite 3 as, in place of the first quantity this is 0, but there is a half there, it doesn't matter, right? So half times 0 is going to be 0, but the second quantity is going to be 1 over 2 times, and in place of integral 0 to t sine t du, you will have to substitute t times sine t. So this is going to be t times sine t. So this is the value that you have got, and this is the solution. So this is the right point to stop. Students, we are given a very simple question to find the Laplace inverse of 1 over s times of s squared positive 1. Now I would be using convolution to solve this, so I would rewrite this as 1 over s times 1 over s squared positive 1. Then I would rewrite it as L inverse of 1 over s asterisk L inverse of 1 over s squared positive 1. I am actually performing the convolution. Now L inverse of 1 over s, this is going to be equal to 1. So that has to be convoluted with L inverse of 1 over s squared positive 1. That is going to be my sine t. Now you can take f of t to be equal to 1 and g of t to be equal to sine t. Now if you want to convolute f star g of t, I'm going to be using integral 0 to t f of t negative u times g of u times du. Now this is also the same if you were to reverse this. Now I'm going to show you that the solution is not going to change at all. So even if I have to perform the reversal of these functions, instead of taking f of t to be 1, if I were to take f of t to be equal to sine t, still it will be, solution is going to be the same. Now f of t is 1, so f of t minus u, let me just write that down here. f of t is equal to 1 and f of t minus u will be the same 1. There wouldn't be any change. And g of t is sine t and g of u is going to be sine u. So therefore, so let me write one more step. Therefore L inverse of 1 over s asterisk L inverse of 1 over s squared positive 1. The convolution of this is, we have already got this. We have got this as 1 star sine of t, and if you want to evaluate this function, this is going to be integral 0 to t f of t minus u, that's going to be 1 times g of u, that's going to be sine u times du. So this is going to be equal to, you have to integrate sine u. Integral of sine u will give you negative cos u, and the limits are 0 to t. Now I substitute the upper limit, I get cos of t. I substitute the lower limit, it's going to be negative or negative, it's going to be positive, so it's going to be cos of 0. So this is going to be negative cos t. Cos 0 is 1, so you get 1 there. I can rewrite this as 1 negative cos t. So what is this? This is this, but what is this? This one is actually the original function. So this is going to be Laplace inverse of 1 over s of s squared positive 1. This I did solely by convolution. So simple. Now just to show you that convolution is commutative, what I wish to do is, now instead of taking f of t is 1, I'm going to take f of t is equal to sine t and g of t is equal to b as 1. So from here the convolution is, I'm going to apply this convolution, f star g of t is equal to integral 0 to t. It's not f of t minus u, I'm going to be using g of t minus u with f of u times du. So this is what I'm going to be using. So from here, if I were to apply a g of t minus u, g of t minus u is 1 and f of u is going to be sine u du. So if you were to integrate, you are going to get negative cos u and the limits are 0 to t. That's it. So the same value will be obtained. It doesn't matter. So that's the reason I used to say that convolution is commutative. So this is the end of solution, students. Students were given this question. We expected to find the Laplace inverse of 1 over s squared positive 1 times s squared positive 25. Now I would be rewriting this as Laplace inverse of 1 over s squared positive 1 times 1 over s squared positive 5 squared. Now this can be further rewritten as L inverse of 1 over s squared positive 1 asterisk L inverse of 1 over s squared positive 5 squared. So if I'm able to achieve the convolution of these two quantities, solution is done. Now L inverse of 1 over s squared positive 1 is sine of t, asterisk 1 over s squared positive 5 squared, that's going to be sine 5 times t with a product multiple of 5. So I've got two functions. I can take one function as sine t and the other, in fact I can take one function as f of t, the other function being g of t. It's going to be 1 over 5 times of sine of 5t. Now if you've got a convolution to be performed on two functions, f star g of t, then it's 0 to t f of t minus u times g of u times du. Now from here I can find f of t minus u, which is going to be sine of t minus u, and also I can find g of u, which is 1 over 5 times sine of 5u. So therefore the convolution of these two functions is return us integral 0 to t f of t minus u is sine of t negative u times g of u is going to be sine of 5 times u as a 1 over 5. I can place that 1 over 5 here times du. So this is what we have got. Now we know a compound angle equivalent formula for this, so which is nothing but 2 times of sine A sine B is equal to cos of A minus B negative cos of A positive B. Now I'm going to show you how these two are connected. Now cos of A minus B is cos A cos B positive sine A sine B negative cos of A minus B is cos of A positive B is cos A cos B. This is positive, so it's going to be negative here. So negative sine A sine B. Okay, a parenthesis. So this is going to be, I'm going to rewrite this as cos A cos B positive sine A sine B negative cos A cos B positive, because negative times negative is positive, sine A sine B. Now cos A cos B, negative cos A cos B, these two can be cancelled, these can be added, so it's going to be 2 times of sine A sine B. Now on the left side I got 2 times sine A sine B, so that's what I'm getting, 2 times sine A sine B. So what I would do is, instead of sine A sine B, I can now write, this means my sine A sine B is going to be half times of cos of A minus B negative cos of A positive B. So I can use this formula safely, right? But my A is t minus u and my B is 5u here. So if I were to substitute this, so all of these things are for your understanding. So therefore consider sine of t minus u times sine of 5u. So A is t minus u and B is 5 times u. So this would mean my sine A sine B is going to be 1 over 2 times of cos of A is t minus u followed by a negative sign, my B is 5u, followed by negative cos of my A is t minus u, followed by a positive sign and 5u. So this is what we've got. I can rewrite this as half times cos of t negative u negative 5u. This is going to be negative 6u, negative cos of t negative u positive 5u. That's going to be positive 4u. So I will have to substitute instead of this. So if I were to take this as 2, hence 2 becomes So this is equal to 1 over 5 times integral 0 to t. 1 over 2 is there, so I can have that over here as 2 times, and this is cos of t negative 6u negative cos of t positive 4 times u times du. Now I can rewrite this as 1 over 10 integral 0 to t cos of t negative 6u times du negative integral 0 to t cos of t positive 4u times du. So this is what we have got. Now we will show you, in other words, let's see how to integrate this one. So consider integral cos of t negative 6u times du. Limits are 0 to t. So I'm going to take let t negative 6u be equal to sum p. I differentiate 6 times du is equal to dp. So that means du is equal to negative 1 over 6 times dp. This is what I've got. So hence integral 0 to t cos of t negative 6 times u times du is equal to integral. I'm not going to touch the integral, just I'm going to substitute t negative 6u to be as p and the du to be as dp over 6 with the negative sign. So if I were to integrate this, this is going to be sine p. I get a 1 over 6, I get a negative sign, and I can rewrite this as negative 1 over 6 of sine of my p is t negative 6u, and the limits are 0 to t. That's fine. So all that we have to do is multiply this component with 1 over 6 with the negative sign and then integrate. Of course the integration of cos is going to be sine, so that's what we have done here. So I substitute the upper limit, so it's going to be negative 1 over 6. Substitute the upper limit is going to be sine of t negative 6 times t followed by negative sine of t negative, in place of u you got to substitute, so it's going to be negative 0. So this is going to be negative 1 over 6 sine of t negative 6t, that's going to be negative 5t, and followed by sine of t. Now sine is an odd function, so you get negative 1 over 6 with the negative sine of 5 times t, negative sine t, so that's going to be negative negative positive 1 over 6 times. Okay, so you have this. So this is one component, so you have to have the other component. So probably I can take this as 3. So now we will have to consider integral 0 to t cos of t positive 4 times u times du. Now you can directly integrate this without, because there isn't any negative sign to be worried about. So this is going to be sine of t positive 4 times u. The coefficient of u is 4, so it's going to be 1 over 4 here. The limits are 0 to t. So I apply the limits, I get 1 over 4 times sine of t positive 4t minus sine of t positive 0, because you got to substitute this value 0. So this will give me 1 over 4 times of sine of t positive 4t, that's going to be my sine of 5t. This is going to be negative sine t. So I got this value, I got this value, so I need to put these things into the original 3. So therefore my 3 is going to be 1 over 10. In place of this I need to substitute this, so this is going to be 1 over 6 of sine t positive sine 5t. So I'm going to rewrite it like this: 1 over 6 times sine t positive 1 over 6 times sine 5t. You have a negative sign, I need to substitute this, so 1 over 4 times sine 5t and negative. Since there's a negative and there's a negative, that becomes positive 1 over 4 times sine t. So this is what I've got. Now I can club these things, I can club these two things together, so and these two things together. So this is going to be 1 over 10 times, I take 1 over 6, in fact if I take 1 over 6 out, in fact I need to take sine t out, so this is going to be 1 over 6 positive 1 over 4, right, clubbing this with the sine t, and then I would have to take sine 5t out. So it's going to be 1 over 6 negative 1 over 4 of sine 5t. So this is how it's shaping up. So this is equal to 1 over 10 times, if I take the LCM as 24, it's up to you. You take whatever value you want, because you need to simplify this. So you can be simplified in many different ways. So this is going to be 4 positive 6 times sine t, and this is going to be 4 negative 6 times sine 5t. So I can rewrite this as 1 over 10 times 10 divided by 24 sine 5t. This is going to be negative, so it's going to be 2 over 24 times sine 5t. Of course, you can simplify this. Now you can, if you want to bring this 10 inside, you can do that. So if you bring the 10 inside, this is going to be 1 over 24 times sine t, because 10 and 10 can be cancelled. And if you are bringing this 10 inside, clearly 2 divides here 12 times, so 12 times 10, that's going to be 120. So 120 times sine phi t. So this is the solution to this question. So it's got a little bit of process that is involved, which you have to do meticulously. Students, we're given this question to find the Laplace inverse of 1 over s squared positive 1 times s squared positive 4 times s squared positive 9. Now this is a beautiful question. It's beautiful for the simple fact that it has a denominator which is very impressive. Now what I would do is, foremost, I would like to consider the Laplace inverse of 1 over s squared positive 1 times s squared positive 9. So this, I'm going to be rewriting it as Laplace inverse of 1 over s squared positive 1 times 1 over s squared positive 9, which can be written using the means of convolution as Laplace inverse of 1 over s squared positive 1 asterisk Laplace inverse of 1 over s squared positive 9. Now this is straightforward, but before I could place the Laplace inverse of this, I would like to rewrite this just for the sake of understanding, right? So this is going to be Laplace inverse of 1 over s squared positive 1 asterisk Laplace inverse of, I would like to write 9 as 3 squared. Now Laplace inverse of 1 over s squared positive 1, that is going to be sine t. It's straightforward. Asterisk Laplace inverse of 1 over s squared positive 3 squared, that's going to give me sine 3t with 1 over 3. So I would like to apply convolution for these two functions. Now just for the sake of refreshment, if I have two functions f star g of t, and if I am trying to convolute this is going to be integral 0 to t f of t negative u times g of u times du. This is the formula that we would have to use. So I can clearly take, depends on what you like, whether you want to take this as f of t or this as f of t, it doesn't matter. So what I would do is f of t is equal to sine t, and my g of t is 1 over 3 times sine of 3 times t. Now we're going to apply convolution. So if I've got f star g of t, this is going to be integral 0 to t f of t minus u times g of u times du. So this is what we are going to use as a formula. So f of t is this. So f of t minus u is going to give me sine of t minus u, and g of u is going to be 1 over 3 times sine of 3 times of u. So if we are applying convolution, so hence f star g of t is equal to integral 0 to t f of t negative u, that's going to be sine of t negative u. G of u is 1 over 3 times sine of 3 times u times du. I can rewrite this as 1 over 3 times integral 0 to t sine of t negative u times sine 3u times du. Now this is a product form, so I will either write to I have to convert this into a sum and or difference using the compound angle. Now I will be using this formula. So we know that sine A sine B, 2 times sine A sine B is equal to cos of A minus B negative cos of A positive B. Now I can show that the left side is equal to right side just for sake of confirmation. If I were to expand this, this is going to be cos A cos B, negative sign, so it's going to be positive sine A sine B, negative, so this is going to be cos A cos B. I would say since it's positive, I will have a negative sign, so it's followed by a negative, but there is a negative sign already, so that would mean I will have a positive sine A sine B. Now negative cos A cos B and positive cos A cos B can be cancelled, giving me sine A sine B added with sine A sine B, so that's going to be 2 times sine A sine B. What is that? That's nothing but my left hand side, so this formula is absolutely correct. So that's the reason I would be employing this difference formula for this component, sine of t minus u times sine of 3 times u. Now clearly my A is t negative u and my B is 3 times u. So if I were to substitute this sine of so let me write that down, sine of t negative u times sine of 3 times u can be rewritten as, we don't have a 2 there, so I need to bring the 2 here, so 1 over 2 times cos of my A is t negative u followed by a negative sign, my B is 3 times u followed by a negative sign, and then my cos is my A is t negative u followed by a positive sign, my B is 3u. So this is what I have got. Now this is equal to 1 over 2 times u negative 3u, so that's going to give me cos of t negative 4 times u followed by negative cos of t negative u positive 3u, so that's going to be t positive 2u. So this is what is my outcome for this component. So if I were to take this as 2, so hence I can rewrite 2 as 1 over 3 times parenthesis integral 0 to t, in place of sine of t negative u times sine of 3 times u, I'm going to substitute this, so this is going to be 1 over 2 times cos of t negative 4 times u negative cos of t positive 2u. So this is what I've got. This has to be multiplied with du. Now I got a quantity of 1 over 2, I can take that out, so that will be 1 over 6 parenthesis. So I need to integrate 0 to t cos of t negative 4 times u times du, that's fine, followed by a negative sign integral 0 to t cos of t positive 2u times du. Now this can be rewritten as 1 over 6. Now this is cos of t negative 4u. With the u I got a coefficient of negative 1 over 4. So I need to multiply it by negative 1 over 4. Integrating cos will give me sine. The argument is t negative 4u. Simple as that. But the limits are 0 to t. So you can substitute that. Followed by negative, I need to integrate cos of t positive 2u. So that's going to give me 1 over 2 times sine of t positive 2u. The limits are 0 to t. So that's it, fair enough. Now if you were to, I want to place 1 over 6 as it is, so I'm substituting the upper limit, so it's negative 1 over 4 sine of t negative 4 times t negative sine of t negative 0, this is for this quantity, followed by negative 1 over 2. Substitute the upper limit, sine of t positive 2t negative sine of t, because u is 0, right? Now this is equal to 1 over 6 negative 1 over 4 times t negative 4t. That's going to give me sine of negative 3t followed by negative sine of t. Okay, so that's for this part. Now negative 1 over 2 times of sine of t positive 2t, that's going to give me sine of 3t negative sine of t. Now rewriting negative 1 over 4, this is already the sine is an odd function, so sine of negative 3t would be negative sine of 3t, so that's going to be positive, so it's going to be 1 over 4 times sine 3t, and we have a negative sign, negative, that's going to be positive 1 over 4 times sine t, and negative 1 over 2 times sine of 3t, and this is going to be positive 1 over 2 times sine t. So this is what I've got. So now I need to simplify this. Now I can add these two together, and I can add these two together. So let's do that. So I want to just use this space over here. I know it's a little bit restricted. So 1 over 6 I'm taking it out. So I will take sine 3t out. So that's going to be 1 over 4 from this side, and followed by negative 1 over 2 times sine 3t. Okay, and then I have to simplify this. So followed by positive 1 over 4 positive 1 over 2 times sine t. So this is what I've got. Now if I were to take the LCM as 4, this would give me 1 negative 2, which is negative 1 over 4. For this one is negative 1 over 4. So I can rewrite this as 1 over 6. So as I mentioned to you, I'm taking 4 as the LCM. So if I were to take 4 as the LCM, this will give me 1 negative 2. That's going to be negative 1 over 4 sine 3t. And as I mentioned to you, I take 4 as the LCM. So this would give me 3 over 4. So positive 3 over 4 sine t. So this is what I've got. Now I can rewrite this as 1 over 6 times positive value first. So 3 over 4 sine t negative 1 over 4 sine 3t. So this is the convolution that we started off. Convolution of these two functions. Okay. Now just for sake of simplification, what I can do is I can bring this 1 over 6 inside. So that would mean 3 over 6 times 4 is 24 times sine t negative 1 over 4 times 6, that's going to be 24, 1 over 24 sine 3t. Now 3 divides here 8 times, so I can have this as 1 over 8 sine t negative 1 over 24 times sine 3t. If I were to take 1 over 8, I get sine t negative 1 over 3 times sine 3t. Okay, this is what I have. Now why did I do all this? Because we will have to use this result. So simplification is always a better way whenever we need to use this into solving a bigger problem. So let's move on. Now if you remember, we started off on our quest to solve this question, and the original question was of this fashion. So 1 over s squared positive 1 times s squared positive 4 times s squared positive 9. This was the original question, and we started off rewriting this original question in this fashion. Say 1 over s squared positive 4 times 1 over s squared positive 1 times s squared positive 9, and then we can actually have this to be as 1 over s squared positive 4 asterisk L inverse of 1 over s squared positive 1 times s squared positive 9. Now in the just a few minutes ago we were able to achieve this. So what did we do? We achieved L inverse of 1 over s squared positive 1 times s squared positive 9. Of course, we applied a convolution and then we arrived at a solution for this as 1 over 8 times sine t negative 1 over 3 times sine 3t. Okay, fair enough. So this is done. But what is this? L inverse of 1 over s squared positive 4. What is that? I can always rewrite this as L inverse of 1 over s squared positive 2 squared. So which is equal to L inverse. Of course, I don't need to. I can directly get the transform. So this is nothing but sine 2t, and of course there has to be a multiple of 1 over 2. So this is what is the Laplace inverse of 1 over s squared positive 2 squared. Now we will have to use these two things. So this is equal to 1 over 2 times sine 2t convoluted with 1 over 8 times of sine t negative 1 over 3 times sine 3t. So we need to apply convolution to this. So I will be taking my f of t to be equal to 1 over 2 times sine 2t, and my g of t is 1 over 8 of sine t negative 1 over 3 times sine 3t. Now f of t negative u is 1 over 2 times sine of 2 times of t negative u, and my g of u is 1 over 8 times of sine u negative 1 over 3 times of sine 3 times u. So therefore f star g of t is equal to integral 0 to t f of t negative u times g of u times du. So this is going to be integral 0 to t 1 over 2 times sine of 2 times of t negative u times 1 over 8 of sine of u minus 1 over 3 times of sine 3 of u, and this has to be multiplied with du. So what we can do is we can take 1 over 8 and 1 over 2 out, so that's going to be 1 over 16 integral now 0 to t times. So we've got sine of 2 of t negative u, and that has to be multiplied with sine u negative 1 over 3 times sine of 3 times u. So this is what we have got. Now I can distribute these things, so let me just place the parenthesis. So this is going to be equal to 1 over 16 times integral 0 to t sine of, in fact I can take the 2 inside, so it's going to be 2 times t negative 2 times u times sine u. I want to bring in the du, followed by negative 1 over 3 times integral 0 to t sine of 2 times t negative 2 times u times sine of 3 times u, and you have a du there. Now we know that 2 times of sine a sine b is cos of a minus b negative cos of a positive b. I've already proved this to you, and I can rewrite this as, in fact, sine a sine b is 1 over 2 times cos of a minus b negative cos of a positive b. So if you were to expand this, and you can clearly see that the cos of a cos b will be cancelled with cos a cos b, but sine a sine b will remain. So what we will do, we will use this result. So this one ends, I can rewrite this, ends sine of 2t negative 2 times u times sine of u. I can rewrite this by using this. So I'm going to take a is 2t negative 2u, and my b is b is equal to u. So this is going to be equal to 1 over 2 times cos of a 2t negative 2u followed by negative b negative cos of a 2t negative 2u followed by my b. So this is equal to 1 over 2 times cos of 2t negative 2u negative u. So it's going to be 2t negative 3u followed by cos of 2t negative 2u positive u. So it's going to be 2t negative u. So instead of this I would be using this. Okay, fair enough. Now comes the next part. So we will have to use now sine of 2t negative 2u times sine of 3u becomes, so we need to know what happens to this. So my a is 2t negative 2u and my b is 3 times u. So if I were to use this, this is going to be 1 over 2 times cos of a, so 2t minus 2u minus b negative cos of a 2t negative 2u positive b. So this is 2t minus 2u positive b. My b is 3u. So I can rewrite this as 1 over 2 times cos of 2t negative 2u negative 3u. That's going to be cos of 2t negative 5u negative cos of 2t negative 2u. This is positive 3u, so that's going to be 2t positive u. So we've got this, we got this. So if I were to take this as say sum 3, so hence 3 becomes, so I have to start with 1 over 16. Instead of this I will have to replace this. So integral 0 to t 1 over 2 times cos of 2t negative 3u negative cos of 2t negative u followed by negative 1 over 3 times. Instead of this I will have to replace this. So it's going to be 1 over 2 times cos of 2t negative 5u negative cos of 2t positive u. This is what I've got. So times du. Of course I need to have a du. Okay, so we will have to integrate this. Now I'm going to rewrite this as 1 over 16. This quantity times the differential operator, so 0 to t 1 over 2 times cos of 2t negative 3 times u times du negative 1 over 2 times integral 0 to t cos of 2t negative u times du negative, I can take this 1 over 3 inside, so 1 over 6 times integral 0 to t times cos of 2t negative 5 times u times du positive 1 over 3 times integral, in fact this should be 1 over 6. So when we bring in negative negative positive, that's fine, 0 to t, and this is going to be cos of 2t positive u times du. So this is what we have got. So that's fine. So let's integrate this. So this is going to be 1 over 16 1 over 2 times, I integrate this, I would get sine of 2t negative 3u, coefficient of u is negative 3, it's going to be 1 over 3 with a negative sign. The limits are 0 to t, so we can place the limits. So probably I'll place the limits like this, 0 to t, followed by negative 1 over 2. Integration of this will give me sine of 2t negative u. Coefficient of u is negative. So place that. The limits are 0 to t. Followed by negative 1 over 6. The integration of this would give me sine of 2t negative 5u. Coefficient of u is negative 5, so it's negative 1 over 5. The limits are 0 to t. Positive 1 over 6 times integration of this would give me sine of 2t plus u. Quotient is 1, so the limits are 0 to t. So this is what I've got. Now this is 1 over 16 times 1 over 2 times 1 over 3 with a negative sign, 1 over 6. I substitute the upper limit, so that's going to be sine of 2t negative 3t for the first component, followed by negative sine of 2t minus 0 for the next component. So this is for one part, followed by negative 1 over 2 times negative positive. That's fine. I substitute the upper limit, so that's going to be sine of 2t minus t negative sine of 2t minus 0. That's for this part, followed by negative positive. So that's going to be 1 over 30 times sine of 2t minus 5t for the first part, negative sine of 2t, okay, 2t minus 0. That's okay. So followed by positive 1 over 6 times, substitute the upper quantity, sine of 2t positive t negative sine of 2t positive 0. So that's what I'm getting. Now this is equal to 1 over 16 times negative 1 over 6 sine of 2t negative t. That's sine of negative t. Sine is an odd function, so I can write it as negative sine of t. This is negative sine of 2t. That's fine. Followed by 1 over 2 times sine of 2t negative t. That's going to be sine t, sine of 2t, followed by 1 over 30 sine of 2t negative 3t negative 5t. That is sine of negative 3t. So that's going to be negative sine 3t, followed by negative sine 2t. That's fine. Followed by positive 1 over 6 times. Now sine of 2t plus t, that's sine of 3t negative sine of 2t. So we got that. Okay, so that's this is sine of 2t. So this is equal to 1 over 16 times negative positive. So 1 over 6 times sine t, negative positive 1 over 6 times sine 2t, positive 1 over 2 times sine t, negative 1 over 2 times sine 2t, negative 1 over 30 times sine 3t, positive 1 over 30. This is not positive, it's negative 1 over 30 times sine 2t, and positive 1 over 6 times sine 3t, negative 1 over 6 times sine 2t. Okay, this is what we have got. Now we need to take things common, so I will start with sine 3t first. So sine 3t, so this is equal to 1 over 16 times, I'm taking sine 3t out, so I will get 1 over 6 negative 1 over 30. Okay, that's fine. Next sine 2t, so plus sine 2t, plus sine 2t, so I have a sine 2t, I start with sine 2t, so 1 over 6, I have a sine 2t. In fact, these two things can be cancelled, right? So I have a sine 2t with 1 over 2, and I have a sine 2t. I have a sine 2t here, I have a sine 2t here. So 1 over 2 negative 1 over 30. So anything else? Okay, that's fine. So this is done, this is done, this is done, this is done, this is done. I have a sine t now. So I'm taking sine t out, and I have a 1 over 6 and a 1 over 2. So that's it. So if I were to take the LCM for this, I think I will use this space here. So 1 over 6 negative 1 over 3 0, I'll take 3 0, and this will give me 5 negative 1, right? 6 5 1, so this is going to be 4 over 30, which is nothing but 2 over 15. So this is 1 over 16 times 2 over 15 times sine 3t positive. Now let me use this space here. 1 over 2 negative 1 over 3 0, the LCM 3 0, 15 negative 1, 14 negative 30, 7 over 15, right? This is 7 over 15 times sine 2t, and the LCM is 6. This is 1, 3, 4 over 6, so 2 over 3. So this is 2 over 3 times sine t. So this is the solution for the question that we have seen. So thank you, students. Welcome, students. In this class we will be studying how exactly we can use inverse Laplace transforms for solving application-oriented problems. However, though this topic comes under differential equations, yet I thought it would be much better to also include this with the Laplace transforms. Of course, this has been featured with inverse Laplace transforms, so that you can have an idea where exactly these transforms are being applied. So we got the differential equations: y triple dash positive 2 times y double dash negative y dash negative 2 times y is equal to 0. Given that y at t is equal to 0 is equal to y dash at t is equal to 0 is equal to 0, and y double dash at t is equal to 0 is given to be as 6. So first step, what we will do is we will be taking Laplace, taking LT on both sides. We get, so this is going to be Laplace transform of y triple dash positive 2 times y double dash negative y dash negative 2 times y is equal to L of 0. So L of, in fact, by linear property I can rewrite this as L of y triple dash positive 2 times L of y double dash negative L of y dash negative 2 times of L of y is equal to 0. Now L of y triple dash, now this is equal to s cubed of L of y negative s squared of y of 0 negative s of y dash of 0 negative y double dash of 0. So this is going to be the formula. So we can state here that we know that L of triple dash is this. L of y double dash is going to be s squared of L of y negative s of y of 0 negative y dash of 0. Now L of y dash is s L of y negative y of 0. So these are the formulae we have already come across. So what we will do is we will use these formulas in 2. So therefore 2 can be rewritten as, I would be substituting s cubed of L of y negative s squared of y of 0 negative s times y dash of 0 negative y double dash of 0. So this is for this, positive 2 times L of y double dash. So this is going to be s squared L of y negative s y of 0 negative y dash of 0, followed by negative L of y dash. L of y dash
is s times L of y negative y of 0, so followed by negative 2 times L of y is equal to 0. Now if you were to see the question, y of 0 is equal to 0, y dash of 0 is equal to 0, so we can state that since y of 0 is equal to 0 and y dash of 0 is equal to 0, now what happens here? Y dash of 0 cancels, y of 0 cancels, y of 0 cancels, y dash of 0 cancels, y of 0 cancels, so we need to write the remaining. So this would mean we got s cubed of L of y followed by negative y double dash of 0 positive 2 times of s squared of, that's the only thing remaining, L of y, and then negative s times L of y negative 2 times L of y is equal to 0. So this is what we have got. Now y double dash of 0 is given to be as 6, so we can state that since y double dash of 0 is equal to 6, if I were to take this as say 3, so therefore 3 can be rewritten as, so I just retain it as it is, s cubed L of y negative y double dash of 0 is 6 positive 2 times s squared L of y negative s times L of y negative 2 times L of y is equal to 0. Now what I'm going to do, I'm going to take L of y common, so this is going to be L of y times s cubed positive 2 times s squared negative s, and I've got a negative 2 there, and I've got a negative 6. I can take this negative 6 onto the other side, so that would mean 6 would occur there. So this is what I've got. So this would mean L of y is equal to 6 divided by s cubed positive 2 times s squared negative s negative 2. Now we will have to factorize this. Now the best way to factorize this is by synthetic division. So since 2 is present in a constant term, we can make a choice by using guess and check technique. So the factors of 2 are plus 1 minus 1 plus 2 minus 2. So what I will do is I will take negative 1 as a choice. I'm trying to factorize this. So the coefficient of s cubed is 1, the coefficient of s squared is 2, coefficient of s is negative 1 followed by negative 2. Of course there are various other techniques by which we can zero it in and by several laws available, but that is beyond the scope of this particular question. So I just wanted to make sure that I'm able to achieve the requirement of getting this factorized. So bringing 1 down, 1 times negative 1 will give me negative 1, adding these two will give me 1, negative 1 times 1 would give me negative 1, negative 1 added with 1 will give me negative 2, negative 2 times negative 1 will give me positive 2, this is 0. So clearly this, I can clearly see that s is equal to negative 1 is a factor, I should say is a root. S is equal to negative 1 is a root, so this means s positive 1 is a factor. So I can see that this is a factor. So now we can factorize this. So the quotient in this case is, we started with s cubed, so this is going to be s squared positive s negative 2. This is what we have got. Of course you can further factorize this. What I can do is I can use the technique of factorization and rewrite this as s negative 1 times s positive 2. So you can check this out. S into s will give you s squared, s into 2 will give you 2s, s into negative 1 will give you negative s, negative 1 into 2 positive 2 will give you negative 2. So this is going to be s squared positive s negative 2. So that's simple.
So now what we need to do is we need to take all of this and place this here. So L of y, so therefore we have factorized the right side. L of y is equal to 6 over s negative 1 and then s positive 1 times s positive 2. So now we have to split this using partial fractions. So what I will do, I will rewrite this, consider 6 over s negative 1 times s positive 1 times s positive 2. This is equal to a over s negative 1 positive b over s positive 1 positive c over s positive 2. So if you were to cross multiply, this is going to be a times of s positive 1 times s positive 2 positive b times of s negative 1 times s positive 2 positive c times of s negative 1 times s positive 1. On the left side I got 6. So clearly I can take the value of s to be as negative 1. If s is equal to negative 1, this will vanish. S is equal to negative 1, this will vanish. S is equal to negative 1, this will stay. So this is going to be, and over here all these things will vanish, so giving me 6. So therefore the value of b is 6 over 2 with a negative sign. So I can just retain it as it is. Now similarly I need to find the value of a. So I will try to use this space here. So if I were to substitute s is equal to 1, this will vanish, this will vanish, this will stay. So 2 times, this is 2, and this is 1, 3. So 3 times 2 is 6, right? So I am getting here 6 times a. 6 times a is equal to 6. So this is what I get. So therefore a is equal to 6 over 6. So which is equal to 1. I know that is equal to 1. Okay, but I'm just retaining it like that. So we have got that, and finally we need to obtain the value for c. Now if I substitute s is equal to minus 2, this goes away, this remains. So minus 2 means this is minus 3. So let me put that here. So it's going to be positive 3 times c is equal to 6. Therefore c is equal to 6 over 3. So I got the value for a, b and c. So I've got all the values. So what I need to do, I need to substitute these values here. So if you want to substitute the value of a is actually 6 over 6. So it's 1, but I want to write it as 6 over 6. So this is going to be s minus 1 times 6. And b is 6 over negative 2. So write it as 6 over s positive 1 times negative 2. And c is 6 over 3. So 6 over s positive 2 times 3. We can just get rid of these things. So 2 divides here 3 times and 3 divides here 2 times. So it's going to be 1 over s negative 1. This is negative 3 over s positive 1. This is positive 2 times s positive 2. So this is L of y. Now we need to get y. So from here y is equal to L inverse of 1 over s negative 1. Negative 3, that's 3, right? So 3 over s positive 1 positive 2 over s positive 2. So this is what I've got. So now what I will do is, by linearity, I can rewrite this as L inverse of 1 over s negative 1, negative 3 times L inverse of 1 over s positive 1, positive 2 times L inverse of 1 over s positive 2. So by the shift, this is going to be e raised to the power of t. This is going to be e raised to the power of negative t. This is going to be e raised to the power of negative 2t, which is the desired result. Okay, so this completes the solution for this question, students. We'll move on to the next question. Welcome, students. We've been asked to use the transforms in solving this differential equation. The only thing is that instead of the usual y, we got an x here. So what I would do is I would rewrite this in the following fashion. So I get x double dash negative 2 times x dash and I've got a x there is equal to e raised to the power of t. So I'm taking Laplace transforms on both sides. So this is going to be L of x double dash negative 2 times L of x dash, and L of x is equal to L of e raised to the power of t. Now this is going to be 1 over s negative 1. Now in this case we have already seen that L of y double dash is equal to s squared L of y negative s times y of 0 and then followed by y dash of 0. So this is the formula that we have for L of y double dash. Now we will have to convert this for L of x double dash. So therefore L of x double dash will be s squared L of x negative s times x of 0 negative x dash of 0. Now if you were to see here x is equal to 2, that means at t is equal to 0 the value of x is given to be as 2. So this is going to be 2. So this can be rewritten as s squared L of x negative 2 times s x dash of 0. You can clearly see dx over dt is equal to negative 1. So what you can do is you can substitute the value of negative 1. So that means this is going to become positive. So this is what we have got for L of x double dash. So that is fine. Now we will have to move on in obtaining the transform for L of x dash. So for that we know that L of y dash is equal to s into L of y minus y of 0. So rewriting this for x dash, this is going to be s times L of x negative x of 0. Now this is equal to s times L of x of 0. X of 0 is equal to 2. So we need to substitute the 2. So we've got this, we've got this, we have got for L of x dash. Now we need to substitute it in 2. So therefore I can rewrite 2 as, I'm going to rewrite, in fact, okay, let me take this as 3 and place here 3, right? So I can rewrite 3 as L of x double dash. I'm going to have this as s squared L of x negative 2 times s positive 1. So that's for this term. Negative 2 times L of x dash. L of x dash is s into L of x minus 2. That's fine. So this has to be followed by negative L of x is equal to 1 over s negative 1. Okay, alright, we've got this. Now there is a slight alteration we need to perform. Now the original problem says d squared x over dt squared negative 2 times dx over dt positive x is equal to e raised to the power of t. We are taking the Laplace transform of this. So in this case it's positive x, but I have placed here negative x, so it has to be positive there, it has to be positive there, and nothing of big change except for this positive sign being placed here. Apart from that there isn't any big alteration that we need to do, so just for the sign. So now what I wish to do is I would like to rewrite this as s squared L of x negative 2 times s positive 1 negative 2 times s times L of x. Negative times negative is positive, for positive L of x is equal to 1 over s negative 1. So this is what we've got. Now what we can do is we can take L of x out, and that would mean I get an x squared here, negative 2s and a positive 1 there, and apart from that I got a 4 and a 1, that's 5, and then negative 2s, so negative 2s can be pushed to the other side. So this is going to be 1 over s negative 1 followed by positive 2s and 4 plus 1 5. We push that 5 to the other side to get negative 5. So this is what we've got. Now this is actually s negative 1 raised to the power of 2, right? So I can rewrite this L of x to be as s negative 1 raised to the power of 2. Am I right? So if you were to expand this, you get s squared negative 2s positive 1. That's fine.
is equal to 1 over s negative 1 positive 2s negative 5. So I will have to bring this s negative 1 raised to the power of 2 to the right hand side. So let's do that. So bringing it down, I would get L of x is equal to 1 over s negative 1 raised to the power of 2. That has to be multiplied with this entire component. S negative 1 positive 2s, there's a denominator 1 followed by 5 over 1. So if I were to multiply that, I would get 1 over s negative 1 raised to the power of 3 positive 2 times s divided by s negative 1 raised to the power of 2 negative 5 divided by s negative 1 raised to the power of 2. So this is what I would have. What we need to do, we need to take the LCM and simplify. So I'm going to take s negative 1 raised to the power of 3. This is going to give me 1 positive 2 times s of s negative 1 negative 5 times of s negative 1, which can be rewritten as 1 positive 2 times s squared negative 2s negative 5s positive 5 divided by s negative 1 raised to the power of 3. Now negative 2s negative 5s can be added, 1 added with 5, so that's going to be 2s squared negative 7s positive 6 divided by s negative 1 raised to the power of 3. So this is what we've got. Consider the term 2 times s squared negative 7s positive 6 divided by s negative 1 raised to the power of 3. I want to split them in partial fractions, so I will write it like this: a over s negative 1 positive b over s negative 1 raised to the power of 2 positive c over s negative 1 raised to the power of 3. So you cross multiply, you get a times s negative 1 square plus b times s negative 1 plus c. On the left side you get 2 times s squared negative 7s positive 6. I want to get rid of a term, so I will take s is equal to 1. This will vanish, we're remaining with, we are left with c, but on the left side I get 2 and a 7 and a 6. 6 added with 2 will give me 8, 8 negative 7 will give me 1, therefore the value of c is going to be 1. And now we can take the value of s to be as 0. So if I take s is equal to 0, I would get here a, I would get here minus b, I will have a c here, and then over here is 6, but my c is 1. So if I were to substitute 1 here and move that, so I would have a negative b is equal to 5. That's one equation, right? So let me take this as equation 1. Now I can take s to be as, say, sum 2. If I take s is equal to 2, this would give me a, s is equal to 2, this is going to give me a b and a c. S is equal to 2 squared is 4, 4 times 2 is 8, 7 times 2 is 14, positive 6, and this is going to be giving me 0. But my c is 1, so if I were to push it, I will have a positive b is equal to negative 1. So this is my 2. So I'll write that here. A positive b is equal to negative 1. So my bb gets cancelled. So 2a is equal to 4. Therefore my a is equal to 2. My a is equal to 2. I substitute a is equal to 2. Therefore my b is going to be negative 3. So I got the value of c, a and b. So if I were to take this as probably say sum 4, something like that, we can, therefore I can say, I can rewrite 4 as, 4 can be rewritten as, this entire component is rewritten like this. So 2 over s negative 1 positive of negative 3 over s negative 1 raised to the power of 2 positive 1 over s negative 1 raised to the power of 3. On the left side you got this, right? This is the term you got, but you have to, but this is nothing but L of x. This is nothing but L of x, right? So L of x is this, but we need to obtain x. So this would mean x is equal to 2 times L inverse of 1 over s negative 1 negative 3 times L inverse of 1 over s negative 1 raised to the power of 2 positive L inverse of 1 over s negative 1 raised to the power of 3. Now this is going to give me 2 times e raised to the power of t, that's fine, negative 3 times this. By shifting theorem you are going to get e raised to the power of t, but there is a s squared. So if it is s squared, we can apply the formula of t divided by 1 factorial, right? So this is going to be t divided by 1 factorial. You don't have to write 1 factorial. Positive, this is going to be e raised to the power of t, and this is going to be t squared divided by 2, right? We have already studied this in inverse Laplace transforms. So you get 2 times e raised to the power of t, negative 3 times e raised to the power of t times t. Of course, 1 factorial I have not written. You can easily understand that. Now if you want, you can rewrite, this is my solution. Okay, this is my x. So with this we can complete, or I should say we can stop over here. This is the right place to stop. Welcome students, we are expected to solve this question. D cubed negative 3 times d squared positive 3 times d negative 1 of y is equal to t squared times e raised to the power of t, with y being given at t is equal to 0 to be 1, at t is equal to 0, y dash of 0 is equal to 0, and y double dash of 0 is equal to 2. Now what I would do is I would just start off the solution by saying given. So I'm going to rewrite the question in this fashion: y triple dash negative 3 times y double dash positive 3 times y dash negative y is equal to t squared times e raised to the power of t. Right, now I'm going to be taking Laplace on both sides, taking Laplace transform on both sides. We get, so what do we get? We get L of y triple dash negative 3 times y double dash positive 3 times y dash negative y is equal to L of t squared e raised to the power of t. Now first let us evaluate what is Laplace transform of t squared. So this is going to be equal to 2 factorial over s raised to the power of n positive 1, which can be rewritten as 2 factorial divided by s raised to the power of 3, right? Because in fact I don't have to write it as n positive 1, in fact it should have been 2 positive 1, but I just want to use the Laplace transform of t raised to the power of n, which is written as n factorial divided by s raised to the power of n positive 1. We need to apply the shift because we have been given L of t squared times e raised to the power of t. So that is going to be, the coefficient of t is 1, so we will have to subject this to the shift of s negative 1. So this is going to be equal to 2 over s negative 1 raised to the power of 3. So we have got the right hand side. Now the left hand side, by linear property, I am going to write it as L of y triple dash negative 3 times L of y double dash positive 3 times of L of y dash negative L of y. Of course on the right side it's 2 over s negative 1 raised to the power of 3. Now what I wish to do is I would like to use the formula for this. So what is the formula? If I were to use the formula for L of y triple dash, which we already know, it's going to be s raised to the power of 3 Laplace transform of y negative s times y of 0, of course the degree is 2 here, followed by negative s of y dash of 0 negative y double dash of 0. This entire thing is for L of y triple dash. Now followed by negative 3 times of L of y double dash, that's going to be s squared of L of y negative s of y of 0 negative y dash of 0, followed by 3 times of L of y dash, that's going to be s into L of y negative y of 0 followed by L of y
Of course, this is equal to 2 divided by s negative 1 raised to the power of 3. Okay. Now, what are we given? Let me use this space. We are given that y of 0 is equal to 1, y dash of 0 is equal to 0, and y double dash of 0 is equal to 2. So y dash of 0 we have to get rid of that. So y dash of 0 is 0. This goes off. This goes off. Anything else? Okay, that's it. Next, y of 0 is equal to 1 and y double dash of 0 is equal to 2. So we will have to substitute these values. So s cubed L of y negative s squared, y of 0 is 1. I don't have to place that. Negative y double dash of 0 is 2, followed by negative 3 times s squared L of y negative y of 0 is 1. That's going to be s there. Then followed by 3 times of s into L of y, negative y of 0 is 1, so I need to place that, followed by L of y is equal to 2 divided by s negative 1 raised to the power of 3. So much so for that. So now what I wish to do is I would like to take L of y out. So if I were to take L of y out, I would get s cubed and followed by negative 3 times s squared, and then followed by 3 times s and negative 1, and I am being left with, so let me evaluate the quantities with s. So it's going to be negative s squared and negative positive 3 times s, and that's it, and followed by quantities with constant term. So it's going to be negative 2 and a negative 3, that's going to be negative 5, is equal to 2 over s negative 1 raised to the power of 3. So this is what we have got. So what we're going to do is we will have to do some simplification. So let's do that. So just make sure that you place this to be the implies sign. Okay, so everything looks fine. So what I'm going to do is I'm going to push everything to the right hand side. So this is equal to 2 divided by s negative 1 raised to the power of 3. This is going to be positive s squared negative 3 times s positive 5. So this is what will be the outcome. On the left hand side you got L of y. Now s cubed negative 3s squared positive 3s negative 1. This can be rewritten as s negative 1 raised to the power of 3. Now you can expand this. When you expand this, you get, this is actually a minus b whole cubed formula. So what is that? It's going to be a cubed negative 3 times a squared b positive 3ab squared and followed by b cubed. Right? This is the formula that we got. And before we could simplify this, we will have to bring the term down. So that is very much critical. So L of y, from here I can rewrite this as 2 divided by s negative 1. If I were to bring this down, it's going to be degree 6 followed by positive s squared negative 3 times s positive 5 divided by s negative 1 raised to the power of 3. So this is what I've got. So now what we got to do is we will have to do some simplification with the quantity over here. Now this can easily be simplified and solved, and for this term what I wish to do is I would like to rewrite s squared negative 3s positive 5 as s negative 1 raised to the power of 2. When I expand this, I get s squared negative 2s and positive 1. I get a negative 3s, so I need to get negative 2s, so I add a negative s. Of course I need to have a positive 5, so for that I'm going to add a 4. So I'm going to rewrite this like this. So this is equal to 2 over s negative 1 raised to the power of 6 positive s negative 1 raised to the power of 2 negative s positive 4 divided by s negative 1 raised to the power of 3. Now what I wish to do is I would like to use this algebraic quantities law. A positive b over c can be rewritten as a over c positive b over c. So if I were to use that, then I could rewrite this as 2 over s negative 1 raised to the power of 6 positive s negative 1 raised to the power of 2 divided by s negative 1 raised to the power of 3 negative s divided by s negative 1 raised to the power of 3 positive 4 over s negative 1 raised to the power of 3. Now what I'm going to do is I need to now take care of this. All of these things are solvable. In fact, I can take the Laplace inverse for this, Laplace inverse for this, but this is s, so I need to get rid of that. So what I wish to do is I would like to write this s as s negative 1 positive 1, right? So if I were to do this, I can safely rewrite this. Let us move to the next page, and so let me rewrite that. So I get L of y is equal to 2 over s negative 1 raised to the power of 6 s negative 1 raised to the power of 2 divided by s negative 1 raised to the power of 3 negative s divided by s negative 1 raised to the power of 3 positive 4 over s negative 1 raised to the power of 3. This is what I've got. So I'm going to rewrite this. So this is equal to 2 over s negative 1 raised to the power of 6 positive. I can cancel the degree 2 with the degree 3, so that is going to give me 1 over s negative 1 negative. I'm going to write s as negative 1 positive 1 divided by s negative 1 raised to the power of 3 positive. This is 4 over s negative 1 raised to the power of 3. This can be further rewritten as 2 over s negative 1 raised to the power of 6 positive 1 over s negative 1 negative. I'm going to rewrite this as s negative 1 divided by s negative 1 raised to the power of 3 positive 1 over s negative 1 raised to the power of 3 positive 4 over s negative 1 raised to the power of 3. This can be further rewritten as 2 over s negative 1 raised to the power of 6 positive 1 over s negative 1, and I can take this down with the outcome being 1 over s negative 1 raised to the power of 2 positive 1 over s negative 1 raised to the power of 3 positive 4 over s negative 1 raised to the power of 3. Now this is on the left. I got L of y. This is simplifiable. So now what I wish to do, I need to obtain y, so I will have to apply L inverse for all these terms. So it's going to be L inverse of 2 over s negative 1 raised to the power of 6. However, I'm going to take the 2 out here and write this as 1 over s negative 1 raised to the power of 6 positive L inverse of 1 over s negative 1 followed by L inverse of 1 over s negative 1 raised to the power of 2 L inverse of 1 over s negative 1 raised to the power of 3 positive 4 times L inverse of 1 over s negative 1 raised to the power of 3. Okay. So if you were to apply the shifting theorem first, so it's going to be 2 times of e raised to the power of t, and this is going to be L inverse of 1 over s raised to the power of 6, and this is going to give you positive e raised to the power of t. It's going to be s. L inverse of s is going to be 1, so nothing to worry about that. And this is going to be s negative 1 raised to the power of 2, right? So e raised to the power of t L inverse of 1 over s squared. That's what we get. Positive e raised to the power of t L inverse of 1 over s cubed, and positive 4 times. This is going to be e raised to the power of t L inverse of 1 over s cubed. Okay. So I can apply the L inverse for these terms. So this is going to be 2 times e raised to the power of t. This is going to be t power 5 divided by 5 factorial. Positive e raised to the power of t, negative e raised to the power of t. This is going to be t divided by 1 factorial. positive e raised to the power of t. This is 3. So this is going to be t squared divided by 2 factorial, positive 4 times e raised to the power of t, and this is going to be t squared divided by 2 factorial. Now we can do the simplification. Now we can add these two things together, right? So if I were to take t squared out and 2 factorial out, and if I were to take e raised to the power of t out, this is going to be 1 positive 4, which is going to be 5 times t squared e raised to the power of t divided by 2 factorial. So this one is taken care of. And is there anything else? Okay, I can't do anything with this and this. I need to write them as it is. So what will be the solution for y? I start with the 2 over 5 factorial, okay, and I will write t raised to the power of 5 times e raised to the power of 2 t, followed by t squared, that's the next power, so it's going to be positive 5 over 2 factorial and t squared e raised to the power of t, followed by negative t over 1 factorial times e raised to the power of t, followed by e raised to the power of t. So that is going to be the solution. Now however, e raised to the power of t is common, so what I can do, I can take that out. That's the only thing I can take out, right? So that would give me 2 over 5 factorial times t power 5, positive 5 over 2 factorial times t squared, negative t over 1 factorial and positive 1, and this is going to be my y. So this is the final solution for this question, students. Welcome students, we've been given this question: d squared x over dt squared positive 9x is equal to cos 2t, with x of 0 being equal to 1 and x of pi over 2 is equal to negative 1. Now this is a unique problem, and we will adopt a different approach to solve this question. And foremost, what we will do is I will rewrite the given question as x double dash positive 9 times x is equal to cos 2t. Next, what we will do is I will be taking Laplace transform on both sides. So when I do that, I get L of x double dash positive 9 times x is equal to L of cos 2t. Now since by linearity I can always rewrite this as L of x double dash positive 9 times L of x is equal to L of cos 2t. So let me write it like that. Now L of x double dash, now we know that L of y double dash is equal to s squared L of y negative s times y of 0 negative y dash of 0. Now rewriting this for L of x double dash, this is going to be s squared L of x negative s times x of 0 negative s dash of 0. So if I were to take this as 2, I can rewrite 2, therefore 2 can be rewritten as, in place of L of x double dash I would be substituting this, so it's going to be s squared L of x negative s times x of 0 negative x dash of 0 positive 9 times L of x. Now cos 2t, that's going to be s divided by s squared positive 2 squared, that's going to be 4. Now this can be rewritten with the value. Now it's been given that x of 0 is equal to 1, so we can only take this over here. So this is going to be s squared L of x negative s times x of 0 is 1, so this is going to be 1, so s times 1 is going to be s negative x dash of 0. Now I cannot use x dash of 0 and solve because there isn't a x dash of 0. So what I'm going to do is
I'm going to take x dash of 0 to be equal to some p. So this is going to be some p, positive 9 times L of x is equal to s over s squared positive 4. Now I can take L of x out, so if I take L of x out, I would get s squared here. I have a 9 here, so it's going to be positive 9. I want to move all these things to the other side, so this is going to be s divided by s squared positive 4, positive s, positive p. Now I can move this s squared positive 9 down, so that's going to be L of x is equal to s over s squared positive 4 times s squared positive 9, positive s over s squared positive 9, positive p over s squared positive 9. Now you can use partial fractions, but I've got a technique for this. I'm going to show you this. Now I can rewrite s over s squared positive 4 times s squared positive 9 to be equal to s divided by s squared positive 4 negative s divided by s squared positive 9. Now if you were to take the LCM, s squared positive 4 times s squared positive 9, this is going to give me s times s squared positive 9 negative s times s squared positive 4. Now if you were to expand, this is going to give me s cubed, this is going to give me 9 times s, negative s cubed, this is going to give me 4 times s divided by the denominator. Now positive s cubed, negative s cubed goes away. 9s negative 4s will give me 5s divided by the denominator. The denominator here is s squared positive 4 times s squared positive 9. Now what I wish to show you here is, just without going through the tedious nature of placing or applying partial fractions, I am able to rewrite this quantity as this quantity. The only problem is this can be achieved if I were to place 1 over 5 here. So if I were to, so this is s divided by the denominator is equal to 1 over 5 times this entire quantity, because this 5 will be neutralized once I have a 5 there. That's exactly what I wish to show you. So all these things are for understanding purposes. So what I will do is I will start off by writing this term first, s divided by s squared positive 9 positive p over s squared positive 9 positive 1 over 5 times of this quantity s divided by s squared positive 4 negative s divided by s squared positive 9. So this is what we have got. Now clearly you got a s divided by s squared positive 9, and then you got 1 over 5 of s divided by s squared positive 4, and then you got a negative 1 over 5 times s divided by s squared positive 9. So we can do some clubbings, right? We can club some quantities over here and simplify them. So I'm going to be rewriting this with this. So this is going to be s over s squared positive 9. I got this term, so this followed by this term is going to be negative 1 over 5. I can write it like this. So this and this are clubbed, followed by p divided by s squared positive 9 followed by positive 1 over 5 times s divided by s squared positive 4. So this is what I've got. Now I've got a 9 here, so I need to do something in the numerator because of the presence of the 9 here. So before I could do that, I would like to rewrite this as 4 over 5, right? 1 negative 1 over 5 is 4 over 5 times s divided by s squared positive 9 is written as 3 squared. Okay, fair enough. Positive p times the denominator is s squared positive 3 squared. So if I have a 3 here, I can clearly apply the sign rule for Laplace inverse. So I need to multiply the numerator by 3 and divide it by 3, followed by, I don't have to do anything here, this is 1 over 5 times s divided by s squared positive 2 squared. So on the left hand side, this is going to be L of x. So I need to obtain the x. So x is equal to 4 over 5 L inverse of s over s squared positive 3 squared positive p over 3 times L inverse of 3 over s squared positive 3 squared positive 1 over 5 L inverse of s over s squared positive 2 squared. Now this is going to be 4 over 5 L inverse of s over s squared positive 3 squared. This is going to be cos 3t positive p over 3 L inverse of 3 over sine squared 3 over s squared positive 3 squared. This is going to be sine 3t positive 1 over 5. This is s over s squared positive 2 squared. That's going to be cos 2t. Okay, so what is this? This is actually x. Now the right side it is all t, on the left side it is x. Actually x is a function of t, so we can always write it as x of t. But it is given that, what is given? This is given. It is given that x of pi over 2 is equal to negative 1. So that means the value of t takes pi over 2. So what we need to do? We need to extract the value for p here. So we need to substitute pi over 2 at these points and obtain the value of p. That's exactly what we are going to do. Now when I substitute t is equal to pi over 2, now pi over 2 is 90. This is going to be cos 270. Cos 270 is 0, so this will vanish. This will give me sine 270, which would mean the value of sine 270 is negative 1. So this is going to be negative p over 3. Of course, on the left side, x of t, when t is equal to pi over 2, is given as negative 1. So I need to substitute negative 1 there, followed by t is equal to 90. So that means cos 180. Cos 180 is negative 1. So I get a negative 1 over 5. Okay, so that's the value I get, negative 1 over 5. So I'm going to take all these things and use the space here. I hope you can watch this. So it's going to be negative 1 is equal to negative p over 3 followed by, so I can push this negative 1 over 5 to the other side. So if I were to do that, let me use this space here. So I get negative 1 equal to negative p over 3, negative 1 over 5. I push this negative 1 over 5 to the other side. It's going to be negative 1 followed by positive 1 over 5 is equal to negative p over 3. There's already two negatives, so they will become positive. So that would mean I'll have a positive 12 divided by 5. So this is the value of my p. Now the solution is complete only when you take this p is equal to 12 over 5 and then substitute it in the original system. So I'm going to use this space here. So this means, okay, therefore x is equal to 4 over 5 times cos 3t plus p is 12 over 5, but there is p over 3 here. So 12 over 5 divided by 3, so that's going to be 12 over 15. So 12 over 15 times sine 3t plus 1 over 5 times cos 2t. Okay, so that is the end of the solution for this question. So all you need to do is take the value of p and substitute here. Thank you, students.